Hello there, and welcome to Science for Sleep, where curiosity gets cozy and science takes the scenic route to slumber. Tonight I'd like to invite you to drift with me into a question so simple it almost hides in plain sight. Why is everything, from the smallest drop of water to the grandest planet in the sky, round? Have you ever noticed it? The way bubbles shimmer as perfect little spheres, the way the moon rises as a glowing circle, or even the way your own eyes, two small worlds of vision, hold their gentle curves. It seems the universe, for all its chaos and complexity, has a quiet obsession with roundness, almost as if it prefers soft edges to sharp corners. Before we begin this slow exploration, take a moment to notice where you are right now. Maybe you're lying in bed, maybe you're winding down after a long day, or maybe you're listening somewhere between wakefulness and sleep. Wherever you are, take a deep breath and let your shoulders drop. If you find this kind of gentle wandering relaxing, I'd be ever so grateful if you'd give this video a like, or perhaps subscribe. It helps this calm corner of curiosity reach others who might be searching for a peaceful pause too. So settle in, find stillness, and let's start our quiet journey through the curves of the cosmos. Because somewhere between soap bubbles and stars lies the story of why the universe, in all its vastness, seems to love being round. When you start to look for circles, you realize they're everywhere. The moon, of course, is the most obvious. Its round glow has guided and comforted humans for as long as we've looked upward. But it doesn't stop there. The earth beneath you, the sun that warms it, the drops of rain that fall upon it, all are shaped by invisible hands into spheres or something close to them. Even the stars that fill the night sky, each a ball of glowing plasma billions of kilometers away, have yielded to the same cosmic tendency. And it's not just celestial bodies. From atoms to eggs, from cells to seeds, from the ripples in a pond to the shape of your own pupils, roundness appears again and again. It's so common that we rarely question it. We take it for granted, as though this is simply how things are supposed to look. But nature doesn't choose shapes by chance. Every curve, every contour has a reason written in physics and chemistry. The roundness of the world is not an aesthetic decision. It's a consequence of forces quietly seeking balance. Imagine you're floating in space far from planets or stars. Out here there's no air, no wind, no ground to stand on, only the deep stillness of the void. In this emptiness, matter behaves differently. When enough dust and gas gather together, their gravity starts to pull inward equally from all sides. There's no preferred direction in the vacuum, no up or down, no left or right. So the pull naturally forms something that's the same in every direction, a sphere. That's how stars are born, and planets too. Gravity, by its very nature, sculpts roundness. It's easy to think of gravity as a downward pull because that's how we experience it on Earth. But in truth, it's an inward pull. Every atom of your body is being drawn toward the Earth's center, and the same thing happens with every atom of the planet itself. Over eons, that inward attraction smooths out irregularities. Mountains wear down, craters soften, and the body settles into the most balanced shape it can achieve. The more massive the object, the more complete this rounding becomes. Small asteroids might be jagged and lumpy because their gravity is too weak to reshape them, but large planets, stars and moons, those have enough pull to mould themselves into near-perfect spheres. This isn't just theoretical. Astronomers can see it across the universe. They observe clouds of gas collapsing under their own gravity, spinning, flattening slightly at the poles, but still forming a sphere overall. It's a process so universal it almost feels like a law of harmony, a cosmic agreement between matter and motion. Roundness, it turns out, is the shape of equilibrium, and yet there's more to this story than gravity alone. On Earth, roundness shows up in places where gravity has little to do with it. Think about a raindrop. When a drop of water forms in the air, gravity pulls it downward, yes, but the reason it's round has nothing to do with that pull. Instead, it's the result of surface tension, the tiny invisible cohesion between water molecules. They cling to each other like old friends holding hands, trying to minimize their exposure to the air around them. To do that, they arrange themselves into the smallest possible surface area for their volume, and mathematically that's a sphere. Nature in this case is being efficient. Surface tension and gravity are two sides of the same idea. Both are forces that seek balance, pulling matter inward equally from every direction. Whether you're looking at a star 1,000,000 times the size of Earth, or a droplet barely big enough to glisten on a leaf, the logic is the same. The sphere is balance made visible. When scientists describe a shape as round, they're often talking about symmetry. A sphere is the most symmetrical object you can have. Every point on its surface is the same distance from its centre. No matter how you turn it, it looks the same. That symmetry means stability, and stability is something the universe seems to prefer. From a purely physical standpoint, symmetry minimizes potential energy. It's the lowest energy state possible. In simpler terms, round things take the least effort to exist. Even on a microscopic level, this pattern holds true. Atoms, the tiny building blocks of matter, aren't perfectly spherical in the classical sense, but their electron clouds, the regions where electrons are most likely to be found, tend to form roughly spherical distributions around their nuclei. That's because the forces holding them together, the electromagnetic interactions between protons and electrons, also act equally in all directions. Once again, the universe reveals its preference for fairness, for uniformity, for roundness. Of course, there are exceptions. Nature loves balance, but it also allows for a bit of chaos. Not everything can or should be a perfect sphere. The mountains, the canyons, the rough edges of the moon, they're all reminders that roundness is a tendency, not an absolute. Gravity and surface tension do their best, but other forces, rotation, heat, impact, compete for influence. That's why Earth, though often called a sphere, is actually an oblate spheroid, slightly flattened at the poles and bulging at the equator. It's not perfectly round, but it's close enough that from the distance of space, you'd never notice the imperfection. It's fascinating to think that the very shape of our world is a kind of compromise between gravity's calm insistence and motion's restless energy. Rotation keeps the planet from collapsing entirely inward, while gravity ensures it doesn't fly apart. Together they create something wonderfully stable, beautifully balanced and softly curved. Roundness also plays a role far beyond physics. It influences how life itself organises. The cells in your body, for instance, often take on rounded shapes because it's the most efficient way to contain their contents. Like miniature worlds, they balance internal pressure against their flexible membranes. A spherical form offers the most volume with the least surface area, a clever way to conserve energy and resources. Even at the level of biology, nature follows the path of least resistance, and the result is a world filled with curves. When you think about it, life and the universe share a quiet logic. Where there is competition, there are edges. Where there is cooperation, there are curves. A cell, a droplet, a planet. All of them are examples of cooperation between forces, each part working with the others to create something whole. As you let your mind wander through these ideas, you might start to feel the calm simplicity behind them. It's not just that round shapes are common, they're inevitable. They're what happens when nature stops fighting itself, when energy spreads evenly, when forces balance, when the world relaxes into its most natural state. It becomes round. It's as though roundness is the shape of rest, the geometry of peace. Of course, we humans have always noticed this, even if we didn't always understand it. Ancient civilizations looked up at the sky and saw the sun and the moon as perfect circles, symbols of eternity, divinity, and completion. The circle became sacred long before we knew why it appeared everywhere. It was the shape of unity, the emblem of time, the sign of the heavens' perfection. Even before telescopes or physics, people sensed that roundness carried a kind of truth. Something about it felt inevitable, eternal. and perhaps that's part of why it's comforting to us now. Our brains are wired to recognize patterns, to find safety in predictability. A circle is easy to understand. It has no beginning or end, no harsh edges to threaten or confuse. It feels complete, contained, familiar. That's why so many of our creations mirror it. The wheel, the ring, the eye, the dome, all reflections of the same quiet symmetry that nature has been practicing for billions of years. You could say that roundness is the universe's way of expressing calm. Every time you see a bubble floating, a planet rising, or a drop of water trembling before it falls, you're watching matter at peace with itself. And yet, the story of roundness is far from simple. Each sphere in the cosmos carries within it a history of struggle. Planets formed from collisions, stars born from collapsing clouds, raindrops torn apart by wind before they fall. The calmness we see in their shapes hides the turbulence that created them. Roundness is both an ending and a balance point, the place where opposing forces finally agree to rest. It's humbling to realize that this same principle applies to you, to every heartbeat, every breath. The shape of your eyes, your cells, even the planet you stand on all follow the same rule. The drive toward balance, the gentle inward pull toward harmony. The curve is not just a physical form, it's a reminder that even in chaos, nature seeks softness. If you could zoom out far enough, you'd see this pattern repeating endlessly. Galaxies spiraling in graceful arcs, stars orbiting their centers, planets turning in circles, moons following their hosts, and deep within all that, tiny particles spinning around nuclei. From the smallest scales to the largest, the roundness repeats, like a signature written across existence. The next time you glance at the sky or watch a drop of water fall, think of it as the universe's quiet handwriting. A message written in geometry saying, this is how energy finds rest. This is how matter learns to breathe. We began tonight with a simple question. Why is everything round? And already the answer is unfolding into layers. Gravity, surface tension, energy, balance, life itself, all conspiring toward the same shape. The universe, it seems, has a favourite form, and not by accident. As we move deeper into this story, we'll see how those forces, gravity especially, continue this cosmic sculpting. How they don't just shape stars and planets, but everything that dares to exist between them. If you were to hold a ball in your hands and let it go, you'd see gravity at work in the simplest way possible. The ball falls. But that small, familiar moment hides a force that shapes everything from your teacup to the galaxies themselves. It's strange, isn't it, that something so ordinary could also be the architect of stars. We live with gravity every moment of our lives. It keeps our feet on the floor, our oceans anchored, our atmosphere wrapped around us like a soft blanket. Yet the real power of gravity is not in how it pulls things down, but in how it pulls everything inward, gently, persistently, and symmetrically. You might think of gravity as an invisible sculptor. It doesn't carve with sharp tools or sudden movements. It works slowly, quietly, almost patiently, over spans of time so vast that our human sense of duration feels almost useless. Millions of years, billions even, are the increments in which gravity speaks. And what it says, over and over again, is this: come closer, find balance, let go of jaggedness, and settle into the calmness of a sphere. To understand why, imagine a cloud of gas floating in the emptiness of space. It's not a solid object, not even particularly dense, just a mist of hydrogen, helium, and dust drifting through the dark. For millions of years it may remain this way, almost weightless, silent, unnoticed. But even in that stillness, gravity is there. Every particle in that cloud, no matter how small, pulls very slightly on every other particle. At first, these pulls cancel each other out, random and weak. But over time, something subtle begins to happen. a small region becomes just a bit denser than the rest. That tiny imbalance makes its gravity stronger, which attracts more material, which increases the density, which strengthens the gravity even further. It's a feedback loop that, once begun, cannot stop. The cloud collapses inward. As the gas falls toward its own center, it begins to warm. The compression generates heat, and the whole thing starts to spin, because even the smallest rotation in that original cloud gets amplified as it shrinks. It's the same principle you see when a figure skater pulls their arms in to spin faster. What was once a shapeless mass now becomes a whirling sphere of light. A star is born, perfectly round because gravity is pulled equally from every direction. If you were to watch this process unfold, which of course would take more time than you or I could ever witness, you'd see that gravity isn't just a force. It's a kind of negotiation between motion and rest. The gas wants to collapse entirely, to fall inward without end, but as it does, pressure builds, heat rises, and eventually in the core, nuclear fusion begins. That fusion pushes outward, balancing gravity's pull. The result is a perfect equilibrium, inward and outward forces matching exactly. The shape that allows this balance is a sphere. No other form works as evenly, as peacefully. That's why every star in the night sky is round. They may differ in colour, size, or temperature, but their form always returns to this same pattern. Gravity compressing equally from all directions. Fusion pushing back equally in response. Roundness again is not decoration. It's the natural resolution of opposing desires. Planets form in much the same way, though on a smaller scale and with a bit more mess. Around a newborn star, the leftover dust and gas swirl into a rotating disk. Tiny grains bump into each other, stick, and grow. Over millions of collisions, they form pebbles, then boulders, then entire worlds. As these growing bodies accumulate more mass, their gravity strengthens, pulling material toward their centers. Jagged edges soften, irregularities smooth out. Eventually, when a body becomes large enough, usually a few hundred kilometers across, its own gravity begins to overcome the rigidity of its rocks or ice. The object literally crushes itself into a sphere. It's astonishing to realize that gravity doesn't just pull things, it sculpts them. It turns chaos into order, fragments into unity. Even if a planet begins life as a lumpy chunk of rock, gravity will not allow it to stay that way for long. Over time, internal heat and the slow creep of material under pressure will smooth its surface into a ball. The result isn't always perfect. Rotation can cause a bulge around the equator, and impacts can dent the surface. But the underlying structure remains roughly spherical. You can see this progression clearly in our own solar system. The smallest asteroids, only a few kilometers wide, are often irregular, like potatoes tumbling through space. But once you look at larger bodies, Ceres, Pluto, the Moon, Mars, and beyond, they all settle into roundness. It's as though gravity has a threshold of authority. Below a certain mass, it whispers. Above it, it commands. Even the term scientists use for this effect sounds almost gentle. Hydrostatic equilibrium. It describes the state where an object's gravity pulling inward is perfectly balanced by the pressure pushing outward. Hydrostatic might sound technical, but if you picture a droplet of water perfectly still, holding itself together through surface tension, you'll feel the same logic at play. Balance, stability, no corners. This equilibrium extends far beyond planets and stars. Black holes, the most extreme objects in the universe, are also perfectly round. Their gravity is so strong that not even light can escape, but their shape remains the same fundamental pattern, an invisible sphere marking the edge where space and time can no longer continue outward. It's as if gravity, taken to its absolute limit, still insists on the same geometry it used for raindrops and worlds, the curve, always the curve. If you could somehow switch off gravity across the universe, the consequences would be immediate and catastrophic. Stars would stop burning, planets would lose their cohesion, galaxies would dissolve into drifting dust. Roundness itself would vanish. It's gravity that gives everything its place, its boundary, its sense of belonging. Without it, there would be no shape at all. It's worth remembering that gravity, while powerful, is not particularly strong. The magnetic force that holds a paperclip to a fridge is far stronger than the gravitational pull between them. What makes gravity so dominant on cosmic scales is that it never switches off, never repels, only attracts. Over time, that steady, unending invitation draws matter together, no matter how far apart it begins. When Isaac Newton first described gravity, he thought of it as a force acting across space, pulling objects toward each other instantly, like invisible strings. Later, Albert Einstein reimagined it completely. He said gravity isn't a force at all, but the result of curved space-time. Massive objects like stars and planets bend the fabric of the universe around them, and smaller objects simply follow those curves. In other words, things move in circles not because they're being pulled, but because the space they move through is itself curved. Even gravity, in its essence, is round. That's an almost dizzying idea. The notion that the universe itself bends to create curves, that roundness isn't just the result of forces within space, but of space itself. When you look at a planet, what you're really seeing is space folding gently around mass. The planet's roundness is both the cause and the consequence of that curvature. From our perspective on the surface, gravity feels like it points straight down. But from the universe's perspective, there is no down. There's only inward. Every object in space pulls equally in all directions, and the result of all those inward pulls is always a sphere. It's the only shape that can satisfy gravity's endless symmetry. Sometimes you can see gravity's sculpting in action. When a large object like a moon or asteroid breaks apart, the fragments often begin to pull back together, forming a loose cluster. Given enough time, those pieces merge and settle once again into a sphere. You could break a planet to pieces, and gravity would simply begin rebuilding it. It doesn't get tired, doesn't change its mind, doesn't stop until the roundness is restored. There's something poetic about that, though we won't call it poetry here. It's simply the way nature behaves. Patient, methodical, unhurried. Gravity's handiwork can't be rushed. If a mountain collapses, if a crater forms, gravity starts smoothing the roughness immediately, though at a pace so slow we barely notice. Over millions of years, even the tallest peaks are worn down, their debris carried to valleys, their sharpness softened. Given enough time, every world tends toward calmness. On a much smaller scale, gravity also shapes our own planet's balance. It's what keeps our atmosphere wrapped around us. Without gravity, air would drift away into space, oceans would evaporate and follow it. Even our sense of direction would disappear. Every cloud, every wave, every grain of sand is held in place by gravity's quiet persistence. And yet, for something so essential, gravity is still mysterious. Scientists can describe exactly how it behaves, but not entirely why it exists. We can measure it, calculate its strength, predict its effects, but the underlying cause, the reason matter bends space-time the way it does, remains one of the great open questions of physics. We understand gravity's results perfectly well. The process by which it rounds planets, forms stars, and orders galaxies is well known. But the source of its power, the essence of that inward pull, still hums beyond our full comprehension. Perhaps that's part of its beauty. There's something comforting about a force that both explains so much and still keeps a secret. It reminds us that the universe doesn't give away all its answers at once. It invites us to keep asking, keep looking upward, keep wondering. Every time you see a photograph of Earth from space, you're looking at gravity's masterpiece. The blue marble, as astronauts called it, perfectly curved, glowing softly against the black. The oceans curve because the planet curves. The clouds swirl in patterns that follow its shape. Even the thin film of atmosphere hugging the surface does so because gravity holds it close, rounding it gently to fit. It's a vision of balance so perfect it almost seems deliberate, but it isn't. Just the natural outcome of the simplest rule. What pulls equally from every direction will always form a sphere. Think too of the sun that warms you. Its light reaches across space because its mass holds itself together through gravity's compression. Inside that star, hydrogen atoms fuse to become helium, releasing energy that travels for 8 minutes before touching your skin. All of it, every ray of sunlight, every spark of warmth, is possible only because gravity made the sun round enough, dense enough, stable enough to burn steadily for billions of years. The roundness of the sun is the reason daylight exists. Even light itself, which has no mass, bends when it passes near something massive. That bending, known as gravitational lensing, reveals how thoroughly gravity shapes space. When we peer at distant galaxies, their light is often distorted into circles or arcs by the gravity of other galaxies in between. The universe literally curves light into rings. The phenomenon has a fitting name: Einstein rings, perfect circles, made not of matter, but of the paths light takes when it follows the warping of space. It's difficult not to feel some quiet admiration for the consistency of it all. From atoms to galaxies, from sunlight to raindrops, everything follows the same quiet rule. Gravity doesn't demand roundness for beauty's sake. It creates it because that's the form in which energy rests most peacefully. No direction stronger than another, no side favoured, just balance. If you step outside on a clear night and look up, you'll see that harmony written everywhere. The moon's bright curve, the distant planets glowing softly, even the stars arranged across the dome of the sky, all circles within circles, gravity's endless pattern repeated on every scale. It makes you wonder, doesn't it, whether roundness might be more than just a coincidence of physics. Maybe it's the universe's simplest expression of order, a kind of signature left behind by the laws that hold everything together. Every curve, every sphere, every orbit is a reminder that even in infinite space there's a pattern of calm trying to emerge. And so, the next time you watch the moon rise or see sunlight reflect in the eye of a raindrop, remember that you're seeing the same story told over and over again. Gravity's hand, unseen but certain, drawing everything toward the same resting shape. The curve is not an accident. It's the natural breath of the universe, the quiet exhale that turns chaos into something round, steady and whole. When you look up at the night sky, it's easy to think of the universe as still. The stars seem frozen in place, the moon drifts slowly, the constellations rise and set with the rhythm of the days. But that stillness is an illusion, a trick of distance and time. In truth, nothing in the universe is ever motionless. Every star, every planet, every particle is spinning, orbiting, drifting, turning. The entire cosmos, from the smallest atom to the largest galaxy, is in constant motion. Somewhere along the way, the universe learned to roll. That might sound poetic, but it's quite literal. The roundness we spoke of before doesn't just appear out of stillness, it emerges alongside motion. Rotation is built into the very fabric of creation. The planets turn, the stars spin, galaxies whirl in immense spirals, and even the atoms within your body are made of particles forever in motion. Every bit of matter carries with it a trace of angular momentum, that strange property of spinning things that seems impossible to get rid of once it starts. To understand where that motion came from, we have to go back to the beginning. Not just the birth of stars or planets, but the birth of everything. After the Big Bang, the universe was not yet the elegant spread of galaxies and constellations we see today. It was a sea of hot, dense particles and radiation, expanding outward at unimaginable speed. And yet, even in that chaos, there were imperfections, tiny fluctuations in density, slight unevenness in the distribution of matter. These tiny wrinkles were enough. they became the seeds of every structure that would ever exist. As the universe expanded and cooled, gravity began its patient work. Those slightly denser regions pulled in more matter, growing ever more massive, while less dense areas emptied out. The growing clumps of matter began to attract gas and dust from all directions, but the universe rarely grants perfect symmetry. Even a small imbalance, a tiny nudge of momentum from one side, was enough to start a slow rotation. Once matter starts spinning, it keeps spinning, unless something stops it. But in the vast emptiness of space, there's nothing to stop it. That's why, as clouds of gas collapsed under gravity, they began to rotate. The same principle applies everywhere. When something shrinks, it spins faster. The figure skater pulling in their arms, the child spinning on a chair, the collapsing cloud of hydrogen, they all obey the same law of angular momentum. It's a kind of cosmic conservation rule. Motion, once begun, doesn't simply vanish, it concentrates. As the cloud collapses further, that spin flattens it. Instead of pulling straight inward, the motion spreads out around the axis of rotation, forming a disk. The material moving along the equator resists the inward pull because of its speed, while the poles continue collapsing more directly. The result is a sphere at the centre surrounded by a thin spinning disk. From this disk, planets are eventually born. The entire architecture of solar systems, the way they flatten, the way planets orbit along the same plane, comes from that simple, ancient spin. It's mesmerizing to think that everything in our solar system moves in roughly the same direction because of a twist that began billions of years ago in a single collapsing cloud of gas. The planets, the asteroids, even the tiny grains of dust in the rings of Saturn all carry the memory of that first spin. The universe learned to roll, and it never forgot. On larger scales, this pattern repeats. Galaxies themselves formed through the same gravitational dance. Immense clouds of matter drew together, began to rotate, and flattened into disks. Stars formed within those disks, each with its own miniature system of orbits and rotations. The Milky Way, the galaxy that holds our sun, spins like a vast pinwheel, turning once every 200 million years. From our vantage point, that's too slow to notice. But across the billions of years of cosmic history, that rotation is steady, reliable, eternal. You could almost imagine the universe as a great ballet of spheres, each spinning gracefully through space, each carrying within it the momentum of its birth. Every spin a remnant of that first unevenness, every orbit a continuation of that primordial roll. When scientists measure these rotations, they find something curious. The spin of planets and stars isn't random. It often follows specific patterns, with smaller objects spinning faster, larger ones slower, and everything influenced by its position within a system. For example, the Sun, enormous as it is, rotates more slowly than the planets orbiting it. Jupiter, on the other hand, spins faster than any other planet, completing a rotation in less than 10 hours. The balance between gravity and rotation defines not just shape, but also behaviour. That balance is delicate. Too much spin and an object flattens dramatically, bulging at the equator like a stretched rubber ball. Too little, and it collapses more completely, becoming a near-perfect sphere. Earth sits comfortably in between. It spins once every 24 hours, enough to create a small equatorial bulge, about 21 kilometers wider than it is tall. You might not see it standing on the ground, but from space it's measurable. It's our planet's subtle reminder that it's not perfectly round, just comfortably so. The moon spins too, though much more slowly. It rotates at exactly the same rate it orbits Earth, which is why we always see the same side. This synchronization, called tidal locking, is another of gravity's long, patient achievements. Over millions of years, gravitational interactions between Earth and the Moon exchanged energy until both found a rhythm that wastes the least motion. The result is a relationship of stillness in motion. One world turning endlessly while always keeping the same face toward the other. Even the sun's surface is not still. It rotates faster at its equator than at its poles, a difference caused by the fact that it's not solid but made of plasma. Charged particles flowing and shifting like a restless ocean of fire. That uneven rotation drives magnetic storms and solar flares, immense eruptions of energy that can stretch far into space. Beneath that turbulence, though, the overall pattern remains the same, a vast sphere turning in endless rhythm. Rotation gives the universe structure. Without it, the planets wouldn't have day and night. There would be no sunrise or sunset, no seasons, no gentle spin to distribute heat and light. A world that didn't rotate would be frozen on one side and scorched on the other. Life as we know it would struggle to find a home there. So, when you watch the sun dip below the horizon, or the moon rise from the sea, you're witnessing the quiet consequence of that ancient spin, preserved across billions of years. But rotation does more than define days and nights. It also shapes the very stability of worlds. As a planet spins, its mass redistributes slightly outward at the equator, which can influence the orbits of satellites, the flow of oceans, even the path of air currents. On Earth, the rotation creates what's called the Coriolis effect. The reason winds curve across the planet and storms spin in different directions depending on the hemisphere. The motion that began in a collapsing cloud now determines the path of every breeze and the dance of every raindrop. You can even feel the Earth spin in subtle ways, though we rarely notice it. When you stand at the equator, you're moving at over 1,000 miles per hour relative to the planet's axis. The air, the ground, and you all share that speed, which is why it doesn't feel like movement at all. But if Earth were to stop suddenly, the atmosphere would keep moving, and the results would be catastrophic. Everything on the surface would be swept into chaos. It's a humbling reminder that even the calmest day depends on the planet's constant, steady rotation. The beauty of motion in the cosmos is that it's not random noise. It's organized chaos, shaped by gravity's rules. The spin of one object influences the orbits of others. Moons tug on planets, planets pull on stars, stars orbit the centers of galaxies, and galaxies themselves drift through clusters, each with its own motion relative to the others. It's an infinite hierarchy of rotation, a universe built on turning. Even time itself, in a sense, was measured first by this motion. Long before clocks or calendars, humans watched the sky to mark the passing of days and seasons. The rotation of Earth gave us the day. The orbit around the sun gave us the year. The phases of the moon gave us months. Every measure of time we use is rooted in the steady, repetitive roll of celestial bodies. The universe spins, and we count its turns. If you trace this pattern inward, you'll find that the very particles inside atoms have their own forms of spin. It's not spin in the everyday sense, not like a ball turning on an axis, but a kind of intrinsic angular momentum built into the fabric of quantum mechanics. Even at the smallest scales, the universe cannot sit still. Everything moves, rotates, oscillates, vibrates. There is no perfect stillness anywhere. And so, from the subatomic to the cosmic, the theme continues. Motion and roundness, shape and spin are inseparable. You can't have one without the other. Gravity pulls inward, rotation spreads outward, and together they create stability. A planet that spins too slowly might deform under its own pull. One that spins too fast might fling its outer layers away. The sweet spot in between, that delicate harmony, is where worlds thrive. The fact that so many planets, moons and stars achieve that balance is a quiet miracle of physics. No one planned it, no hand guided it. It's simply what happens when matter obeys its own laws over enough time. The universe doesn't need intention to find grace. There's something deeply comforting about knowing that. The same motion that keeps the stars turning also keeps you here, under gravity's steady pull, spinning gently through space. You're part of that same ancient momentum, a passenger in the great rotation that began billions of years ago. Every breath you take, every moment you live, unfolds on a planet that's endlessly rolling beneath your feet. And the most remarkable part? That spin never truly stops. Long after the sun fades and the galaxies drift apart, rotation will continue in whatever forms remain. Even when the universe cools and darkens, when the stars burn out and the atoms slow, the echoes of that first turn will persist. Motion doesn't vanish. It only spreads thinner, slower, wider. The universe will keep rolling quietly, endlessly. It's easy to forget that when you look at the stars, what you're seeing are worlds in motion. The light from them took years, sometimes millennia, to reach you. In that time, they've turned countless times on their axes. Their planets have orbited, their moons have circled. The picture you see is a frozen frame of an endless dance. The stillness of the night sky is only a pause in perception. The reality is movement beyond measure. So when you lie beneath the stars and feel the earth turning, even if you can't sense it directly, you're participating in that grand rotation. The same forces that spun the galaxies are spinning you now. The same gravity that drew clouds into spheres once set them into motion. The same angular momentum that shaped worlds still hums quietly through the space around you. The universe, for all its vastness, moves as one. And just as motion brings stability to the stars, it brings rhythm to life. The turning of the earth regulates light and darkness, sleep and waking, the pulse of days. Plants open and close their leaves in tune with that rhythm. Animals migrate. Tides rise and fall. Even the chemistry within your cells follows cycles that mirror the turning of the world. You're built to move with the spin of the planet, to live within its rotation. The motion that began in cosmic gas clouds now beats inside your body's clock. If the universe's earliest lesson was how to form spheres, its second was how to keep them moving, and in that motion lies everything we recognize as time, balance, and existence. The universe learned to roll, and that roll became the heartbeat of creation. If you stand near a window on a quiet afternoon and watch the rain, you can see the universe repeating itself in miniature. Each drop that slides down the glass carries within it the same story as a planet or a star. It forms, it falls, it reshapes itself under pressure, and for a brief fragile moment it becomes a perfect sphere before it breaks. The raindrop is in many ways a tiny world of physics, the simplest, most intimate expression of the same forces that round entire planets. At first glance, a raindrop might not seem that round. When you picture one, you might think of the teardrop shape used in drawings or logos, with a rounded bottom and a pointed top. But that shape is an illusion, born of motion. The raindrop doesn't fall because of its shape. It changes shape because it's falling. In truth, when it first forms in the clouds, it's almost perfectly spherical. Inside a cloud, water vapor gathers around microscopic particles, bits of dust, salt, or pollen, forming tiny droplets. These droplets float easily in the air, carried by updrafts, endlessly colliding, merging, and growing. Each one is held together by surface tension, that subtle force acting along the surface of a liquid that pulls it inward, minimizing its area. Surface tension is, in essence, cohesion in action, the same molecular friendship that holds water together and gives it the remarkable ability to cling, bead, and flow. If you could see the forces at play inside a droplet, you'd notice that every molecule on its surface is tugged by its neighbours. Those tugs are equal in every direction, creating a balance of energy that naturally results in a sphere. It's not magic, it's mathematics. The sphere has the smallest possible surface area for a given volume, and nature, always conserving energy, prefers efficiency. Every drop from the smallest mist to the heaviest rain begins as a perfect balance of internal and external pressure, a floating bubble of harmony. But that perfection doesn't last. As the droplet grows heavier, gravity begins to pull it downward. It accelerates through the air, gathering speed. Air resistance pushes against it, flattening its bottom slightly. By the time it's large enough to fall as rain, it's no longer a perfect sphere. Instead, it takes on the shape of a squashed ball, slightly domed on top and flatter below, like a tiny hamburger bun. If it grows larger still, the air pressure eventually causes it to wobble and break apart into smaller droplets, each of which becomes round again as it continues to fall. There's something beautifully self-correcting about that process. No matter how the droplet deforms, it always returns to roundness when it's left alone. It can be stretched, spun, shaken apart, and yet, as soon as the external forces calm, the molecules find their way back into that same minimal energy configuration. It's as though water knows where to rest. This same principle governs bubbles too, though they're made not of pure water, but of thin films of liquid enclosing air. The air inside a bubble pushes outward, while surface tension pulls inward, and the equilibrium between those forces again produces a sphere. You can try to make a square bubble if you like. You can even build a cube-shaped wireframe and dip it in soapy water, but the surface will still curve toward roundness wherever it can. If you blow two bubbles that touch, they'll merge into one, dividing themselves with a perfectly curved wall that balances the pressure on each side. When multiple bubbles meet, they arrange themselves with mathematical precision, always seeking the configuration that uses the least energy. You can find the same geometry in foam, in soap films, even in the membranes of living cells. Surface tension isn't just a property of liquids, it's a quiet architect of form. The science of surface tension goes far beyond droplets and bubbles. It shapes every interaction between liquids and gases, between water and air, between oil and skin. It's the reason some insects can walk on the surface of a pond, their legs supported by an invisible elastic sheet. It's the reason small beads of dew cling to grass in the morning, trembling but never falling until the balance tips. And it's the reason a single drop of water resting on a leaf can hold its perfect roundness long enough to catch the light of the rising sun. When you watch such a droplet closely, you're seeing the same physical laws that sculpt galaxies, only expressed on a scale your eyes can hold. The forces are different in strength, but identical in kind. Gravity pulls on the raindrop just as it pulls on a planet. Surface tension acts inward just as gravity does, equal in every direction. In both cases, balance creates roundness. It's a perfect demonstration of the idea that nature repeats itself across scales, from the cosmic to the microscopic. There's another reason droplets fascinate scientists. They behave in ways that are both simple and mysterious. When two droplets collide, they might merge or bounce off each other, depending on their speed, size, and the humidity around them. If they merge, the combined droplet briefly oscillates, vibrating between stretched and compressed shapes before settling back into a sphere. You can even hear that vibration if you magnify it enough. It produces a faint, almost musical frequency. In a way, the raindrop sings as it finds its balance again, and that vibration, gentle as it seems, is a kind of reminder that stillness in nature is never absolute. Even the most perfect sphere is always trembling, adjusting, responding to forces around it. The droplet surface shifts with every gust of air, every change in pressure or temperature. It's a tiny, living dance of molecules, endlessly moving toward equilibrium but never quite reaching it. If you've ever seen a droplet resting on a hot pan, dancing and rolling without evaporating immediately, you've witnessed what physicists call the Leidenfrost effect. A thin layer of vapour forms beneath the droplet, keeping it afloat. It skates across the surface, spinning and shivering, retaining its roundness because the vapour cushion keeps the liquid from spreading out. That same balance of forces, gravity, pressure, heat and surface tension, creates an unexpected grace. Even in heat, the sphere persists, and yet, despite how common and familiar it is, the raindrop remains an object of study. Scientists and engineers study droplets to understand how clouds form, how rain begins, how sprays and mists behave in everything from medicine to rocket fuel. The physics of droplets governs inkjet printers, fuel injectors, and even how we breathe. Each exhaled mist of moisture follows the same rules. In every drop of water, the universe's geometry quietly repeats itself. When you consider that the same physical laws apply to stars and raindrops alike, it becomes difficult to see them as separate phenomena. Both are expressions of the same tendency toward balance, the same push and pull between opposing forces. The roundness of a raindrop is, in essence, gravity's signature written in miniature. Of course, in the grand scheme of things, the forces involved are small. The gravitational pull on a raindrop is almost nothing compared to the pull that shapes a planet, but the principle is identical. Nature doesn't need size to repeat its wisdom. It works with whatever it has, atoms or galaxies, applying the same rules of stability everywhere. If you could slow time and watch a raindrop forming, it would begin as invisible vapor, molecules drifting freely in the air. As they cool, they cluster together, forming a tiny nucleus that grows molecule by molecule. The cluster pulls itself inward, wrapping its surface tight until the drop becomes dense enough to scatter light. At that point, it's no longer invisible. It glints, catching the faintest reflection of the sky around it. It grows, it falls, it reshapes, and when it lands, in a puddle, on a leaf, or on your skin, it merges with other water, its individuality dissolving but its roundness preserved in memory. In that moment, it has completed the same cycle as a world. Birth, growth, descent, and union. The scale may differ, but the physics is shared. Every drop of rain is a small echo of planetary formation, a rehearsal of gravity's design in liquid form. There's a quiet satisfaction in realizing how universal that pattern is. You can look at the simplest act of water beading on a window and trace it back to the origins of the cosmos. The same laws that shape the first stars are working right now in the tiny trembling droplet beside you. And though surface tension seems small compared to gravity or electromagnetism, it's one of the key players in the texture of life. Without it, raindrops wouldn't form, clouds wouldn't gather, and water wouldn't move as gracefully as it does. Rivers would not ripple, leaves would not hold dew. Even your own blood flowing through capillaries relies on similar forces, cohesion, adhesion, and pressure, to move smoothly. The physics of roundness is not limited to the skies. It flows through you. In the quiet repetition of rainfall, there's a sense of order, a soft rhythm that mirrors something ancient. The droplets gather, fall, and scatter, each one unique but governed by the same laws. It's a reminder that the universe doesn't need grand displays to express its symmetry. Sometimes it does so through something as small as the shape of a tear or the glint of a raindrop under a streetlight. If you've ever caught a drop on your fingertip and watched it cling there, trembling before it slides away, you felt the balance directly. The weight of gravity pulls it downward, while surface tension resists. For a second, those two forces are equal. Then one wins. The drop falls. It's a simple event, but behind it lies the same principle that governs everything from tides to galaxies. Equilibrium giving way to motion. The beauty of physics, especially at this gentle scale, is how it turns ordinary moments into something extraordinary. Every drop, every shimmer, every ripple is the universe performing the same equation over and over again, finding the most elegant path between forces. The fact that it produces roundness again and again isn't coincidence. It's a testament to how balance expresses itself through form. Even artists and architects have taken inspiration from this. The dome, the arch, the curve, all are reflections of natural efficiency. A circle distributes pressure evenly, resists collapse and wastes no energy. The same rule that makes a raindrop stable makes a bridge strong and a planet round. Humans didn't invent curves, we copied them. It's easy to overlook something so common. Rain falls, puddles form, and we rarely think about the geometry of it all. But if you pause and look closely, you can see the same elegance that governs the stars playing out in a patch of wet pavement. The droplets merge, flow together, create ripples that expand in perfect circles. Those ripples, too, are the language of symmetry, waves spreading outward evenly from a single point. Every splash is a lesson in balance, and perhaps that's why rain has always felt soothing. Beyond the sound, beyond the smell of wet earth, there's something inherently calming about watching the repetition of those circular ripples. Each one expands until it disappears, replaced by another. It's a visual lullaby of geometry. Roundness, motion, and return, again and again. Scientists can describe every equation that governs a raindrop, but the feeling it evokes, that quiet sense of order in the midst of randomness, is something words can only approximate. Maybe that's because what we're really seeing isn't just water falling. We're seeing the universe reminding itself how to be round, one droplet at a time. And when that rain seeps into the ground, joins streams, and eventually returns to the ocean, it completes a cycle as ancient as the earth itself. The same water that falls today may once have been part of the sea that reflected early sunlight, part of a cloud that drifted over continents now long gone. The droplets that form on your window pane tonight might have fallen as snow 1,000 years ago, or as mist on some distant mountain. The form changes, but the roundness returns, always. It's not hard to see why early thinkers saw meaning in these shapes. Circles and spheres became symbols of perfection, completeness, divinity. The heavens were thought to move in perfect circles because they reflected a kind of cosmic order. Even now, long after we've replaced myth with mathematics, we still find comfort in the same forms. A ring on a finger, a wheel turning, a droplet resting, all small reminders of continuity. If you trace every circle you can find, from raindrops to orbits, they all lead back to the same truth. Energy seeks balance, and balance looks like a sphere. The universe, in all its complexity, keeps returning to that shape not because it's simple, but because it's stable. The roundness of a droplet isn't a coincidence of water's chemistry. It's an echo of the same principle that holds the stars together. So the next time rain begins to fall, let it be more than weather. Let it be a small reminder of how everything, from the tiniest bead of water to the largest planet, shares a common language of shape. Each droplet that lands is a quiet translation of cosmic law, written in liquid form, whispering the same message over and over, that in the tension between forces the most natural outcome is peace. When you look around the living world, it doesn't take long to notice that life itself prefers curves. You see it in the roundness of seeds, the smoothness of eggs, the symmetry of eyes. Even at the level of the cell, the shape repeats, softly enclosed, perfectly contained, ready to grow. Roundness, it seems, isn't just a property of planets or raindrops. It's the signature of life as well. We might think of shape as a matter of coincidence, a simple result of how things grow, but in biology, form follows function, and function follows physics. The same laws that sculpt stars and droplets guide the organization of living matter. Whether you're looking at a galaxy or a cell, the principle is the same. Where forces pull evenly, curves emerge. Take the egg. It's one of the simplest and most ancient designs in nature, and one of the most efficient. Birds, reptiles, insects, they've all discovered the same form through evolution, each arriving at variations of the same idea. The egg is a compromise between strength and economy, between protection and growth. It's rounded enough to withstand pressure from outside, but not so perfectly spherical that it can't be safely laid or settled in a nest. The physics of the egg is subtle. Its curved shell distributes stress evenly across its surface. just as a dome or an arch does in architecture. That means it can bear considerable weight. A hen can sit on her eggs without breaking them, because the pressure spreads evenly rather than concentrating at one point. At the same time, the egg's asymmetry serves a purpose. One end is slightly larger, allowing for an air pocket that supplies oxygen to the growing chick. The narrower end helps guide the egg's rolling pattern, preventing it from rolling too far away when it moves. A sphere would roll indefinitely. An egg rolls in a gentle circle, returning to where it began. Even here, nature's geometry is practical. If you look closer at the structure of the shell itself, you'll find another layer of design. It's made mostly of calcium carbonate crystals arranged in a matrix that balances rigidity with permeability. Tiny pores in the shell let gases move in and out, allowing respiration without breaking the protective seal. The shape alone wouldn't be enough without the material, but the material wouldn't function as well without the shape. It's a perfect collaboration between chemistry and geometry. The egg is not only strong, it's efficient. It encloses the maximum possible volume for a given amount of material. The yolk and the albumin inside are suspended in a near weightless balance, the curved inner membrane keeping everything gently separated yet connected. When the chick begins to form, it grows in harmony with that shape. It doesn't push against corners or edges because there are none. The roundness allows life to unfold smoothly, evenly, protected from within and without. You can trace this same principle back through evolution. Long before birds existed, even single-celled organisms took on rounded forms. A sphere is the simplest shape that contains an interior, and life, by definition, needs an interior. A place to hold the chemistry of existence separate from the outside world. The cell membrane, that delicate boundary between life and not life, achieves this separation by curving around itself. The result is almost always round. The logic behind it is the same as that of a raindrop. Surface tension, at the molecular level, pulls the membrane inward from all sides. Inside, osmotic pressure pushes outward. The two forces meet in equilibrium, and the cell finds its natural form. That form isn't random. It's the lowest energy configuration, the most stable arrangement. Roundness is the shape of least effort, and life, like everything else, prefers to conserve energy. As organisms became more complex, they carried that geometry with them. You can see it in blood cells, whose rounded, concave shape allows them to flow smoothly and carry oxygen efficiently. You can see it in the curvature of muscles and organs, designed to expand and contract without tearing. Even the structure of the brain follows the pattern, folded and curved to pack the maximum surface area into the smallest possible space, using the same logic that dictates the design of soap films and droplets. And then there's the eye, perhaps the most literal connection between biology and roundness. The eye is a sphere for a reason. Light entering the eye must be focused precisely to form an image, and the only way to achieve that evenly from all directions is to use a curved surface. The cornea and the lens bend light toward the retina, which lines the interior of the globe like a screen. If the eye were flat, vision would distort with every angle. The sphere solves that, maintaining uniform focus and distance. The shape also allows the eye to move smoothly in its socket, to pivot and follow motion without friction or strain. The muscles that control the eye are arranged around it like cords on a puppet, pulling in gentle cooperation. Each movement, each blink, depends on the roundness that allows rotation. Without it, your world would be static. Even the smallest eyes, those of insects, fish, or microscopic creatures, echo the same logic. They form curved lenses that gather light efficiently, maximizing vision with minimal material. Nature didn't invent new physics for each species. It reused the same principles, adapted at different scales. The curve keeps proving itself. Inside the eye, in the very act of seeing, there's another kind of roundness at play. When light waves enter, they spread as spheres of energy. Each photon moves outward in all directions, a tiny expanding front of electromagnetic curvature. The eye, round itself, meets those spherical waves with matching geometry. In a sense, every act of sight is the meeting of two curves, one from the outside world, one within. There's something humbling about that symmetry. The universe produces light in waves that expand spherically, and living beings have evolved organs shaped to receive those waves most efficiently. The form of your eye is an answer to the form of light. Roundness calls to roundness, but the pattern doesn't stop there. If we shrink our view further, far smaller than any cell, we reach the realm of atoms, the fundamental units of matter, the invisible scaffolding from which everything else is built. For much of history, people imagined atoms as tiny, solid spheres, miniature billiard balls locked together in countless arrangements. That image isn't entirely accurate by modern standards, but it wasn't far off in spirit. The idea of atoms as spherical persists because, in many ways, they behave as though they are. An atom is made of a dense nucleus surrounded by a cloud of electrons. Those electrons don't orbit the nucleus like planets, not exactly, but exist in regions of probability, areas where they are most likely to be found. The shapes of those regions, called orbitals, depend on the energy and angular momentum of the electrons, and while some take on complex forms, the simplest, most fundamental one, the lowest energy state, is perfectly spherical. That means the most stable, most natural configuration of matter at the atomic level mirrors the same shape seen in droplets, cells, and planets. A round probability cloud, evenly distributed in every direction, representing the balance between attraction and motion. The forces at work, electromagnetism instead of gravity, quantum uncertainty instead of pressure, are different in scale but identical in purpose. Once again, balance creates the sphere. When atoms bond to form molecules, roundness sometimes gives way to other geometries, tetrahedrons, planes, chains, depending on how the electrons share space. But even these shapes often arrange themselves into curved or repeating patterns at larger scales. DNA, for instance, coils into a double helix, a spiraling form that's part cylinder, part curve. Proteins fold into globular shapes, their surfaces smoothed by the same search for minimal energy. Even on the molecular level, nature avoids sharp edges. The deeper you look, the more consistent the pattern becomes. Energy flows through curves, not corners. Whether it's the magnetic field around a planet or the electric field around a proton, the lines of force always radiate outward symmetrically. Every interaction, attraction, repulsion, orbit, wave, follows the geometry of the circle. The universe doesn't favour straight lines. We do. Nature, left to itself, bends. This preference for roundness has practical consequences for life. A sphere encloses the most volume for the least surface area, which means it minimises the loss of heat, energy, or resources. For a living cell, that's essential. For an egg, it means efficiency. For an organism with eyes, it means vision that uses light without distortion. In every case, the round shape provides stability and conservation. It's the geometry of survival. You could say, then, that life borrowed its blueprints from physics. When the first simple membranes closed around pools of organic molecules, they didn't have to invent roundness. It was already the easiest solution. And as those membranes grew more complex, forming tissues, organs, and eventually entire creatures, the curves simply multiplied. Each new level of complexity carried forward the same principle. Where forces meet evenly, roundness arises. There's a strange comfort in knowing that your own body is built on those same rules. Every cell, every drop of blood, every structure in your eyes or brain owes its stability to the same balance that keeps planets round. You're not separate from that geometry. You're made of it. The egg holds life's potential. The eye receives the world's light, and the atom binds all matter together. 3 very different scales, yet each one expresses the same quiet symmetry. You can start from the egg and move inward to the atom, or outward to the planet, and you'll find the same logic repeating. Even our sense of beauty seems tuned to this pattern. We find round forms comforting, pleasing, gentle. Circles feel natural to us, while sharp angles feel tense or threatening. That response isn't arbitrary. It's built into our biology, a reflection of what our own bodies are made of. When we see roundness, we recognize something familiar, the equilibrium we carry within ourselves. It's easy to overlook how profound that connection is. The same shape that defines a drop of water also defines the cell that senses it, and the atom that composes both. From the very small to the unimaginably large, roundness links every level of reality in one continuous thread. The forces that sculpt the universe don't just exist around us, they work through us. If you could peel away the layers of scale, zooming in or out infinitely, you'd find yourself moving through a universe that never stops echoing its own geometry. From atomic orbitals to eggshells to planetary orbits, the theme never changes. The roundness isn't decoration, it's the natural consequence of balance seeking itself. Perhaps that's why so many of our own creations, when they last or function well, mimic the same principle. We shape wheels for movement, lenses for sight, domes for shelter. Even in art and design, circles appear instinctively. It's not imitation, it's resonance. The mind recognizes what the universe has already proven to be efficient. And while the forces behind all this can be described with equations, gravity's inverse square law, surface tension's minimization of area, the Schrödinger equation for atomic structure, the feeling they produce, when seen together, is something simpler, a sense of coherence. Everything that exists, from the egg in a nest to the atom in your hand, seems to be participating in the same conversation between forces. It's as if the universe in every form is quietly whispering the same answer. This is how stability looks. The curves of life aren't random. They're the most natural expression of physics under the condition called existence. Each round form, each contained volume, is an experiment in balance that succeeded. It's the reason life can grow, move, and perceive. Without those curves, without the balance that roundness provides, the chain of existence would break. So when you see a robin's egg, or the reflection of an eye, or a model of an atom, you're seeing three manifestations of the same ancient pattern: the shape of protection, the shape of perception, and the shape of matter itself. All variations of a single theme written across creation. And as you think about these shapes softly repeating in every scale of the world, it becomes clearer that nature doesn't play favourites between the living and the non-living. The same rules apply to all of it. The boundary between physics and biology is thinner than it appears. The roundness of an egg isn't so different from the roundness of a planet. Both are containers for energy. Both are shaped by inward and outward pressures. Both are temporary expressions of the same balance. In that sense, every living thing carries a trace of the universe's earliest lessons. Life didn't invent symmetry, it inherited it. The egg, the eye, and the atom are reminders that existence itself began with a preference, not for complexity, not for perfection, but for equilibrium. And when you follow that pattern outward again, beyond the living forms and back into the larger world, you start to see how even the shapes of landscapes, waves, and winds obey the same quiet order. Because nature, in all its variety, continues to smooth what is sharp, to round what is rough, to balance what is uneven. It avoids corners not by choice, but by the logic of energy itself. If you look around your room right now, you'll see corners everywhere. The edge of a table, the frame of a window, the shape of the walls meeting each other. Our human world is full of straight lines and sharp angles, carved and constructed to make sense to our sense of order. We build boxes because they stack neatly, because they fit together, because they make measuring and counting easy. But if you step outside that geometry, if you walk into a forest, Stand by the sea or look up at the night sky. You'll notice something different. Nature rarely builds with corners. Everywhere you look in the natural world, edges are softened, lines are curved, boundaries blend instead of intersecting. Stones wear down into ovals, trees curve as they grow, rivers bend through valleys. The longer something exists in nature, the rounder it becomes, and there's a reason for that. One rooted in physics, efficiency, and time itself. The universe doesn't favour roundness for beauty. It does it because corners are expensive, not in money, but in energy. A corner, by definition, concentrates stress. It's a point where forces meet abruptly instead of flowing smoothly. The more abrupt that meeting, the more energy is stored, and the more likely something is to break, tear, or wear away. Think about what happens when water flows around a rock. The smooth stones you find in a riverbed didn't start that way. They were once jagged, rough, irregular, but every current, every collision, every grain of sand moving past them slowly took away the edges. Over time, the rock became smaller and rounder. It wasn't a random transformation. It was physics doing what it always does, reducing energy gradients, minimizing resistance, distributing force evenly. The sharp parts went first because they bore the most stress. This rule applies everywhere, not just in rivers. A drop of water on a leaf rounds itself because that shape minimizes surface energy. A planet smooths into a sphere because that shape minimizes gravitational potential energy. Even within your own body, your joints and bones have rounded ends to distribute pressure evenly as you move. Nature avoids corners because corners demand extra effort to maintain. In engineering, this same principle is recognized as stress concentration. If you design a metal beam with a sharp notch or a square cutout, that's where it will fail first. The reason is simple. When force is applied, it doesn't distribute evenly around a sharp feature. The molecules at that point are forced to absorb more strain than their neighbours, and eventually they give way. That's why airplane windows are rounded, not square. In early aircraft design, engineers learned this lesson the hard way. The first pressurized planes had square windows, and the repeated stress of flight caused cracks to form at the corners. The solution was as elegant as it was simple. Replace the corners with curves. The failures stopped. Nature, of course, has been designing for far longer than we have. It already learned that edges don't last. The coastline of a continent shaped by waves and wind smooths itself over millions of years. Even the mountains, which rise with jagged peaks, are worn down by the atmosphere, their angles blunted by rain and frost. Given enough time, every sharp feature softens. Entropy, that quiet rule that governs disorder, ensures that energy spreads out and tension dissolves. Corners resist that spreading, and so they can't persist. If you look at living tissues under a microscope, you'll see the same idea in motion. Cells pack together not as squares or triangles, but as rounded polygons that share borders smoothly. When biological materials tear or heal, the edges curve inward. Wounds close in circles, not straight lines. Even the patterns of growth, the spiral of a shell, the curve of a leaf, the arc of a vine, follow mathematical laws that minimize wasted energy. You can trace this pattern back to the mathematics of minimal surfaces. In physics, a minimal surface is one that uses the least possible area to enclose a given volume. Soap films are perfect examples. When you dip a wire loop into a soap solution and pull it out, the film that forms stretches itself into a shape that balances tension equally across every point. If the loop is circular, the film is flat. If the loop is irregular, the film curves itself until the forces equalize. Corners simply can't exist on a minimal surface because the forces there would be unequal. The result is always smooth. That same logic applies in biological membranes, geological formations, even the invisible boundaries between air masses in the sky. Every system governed by energy seeks to minimize gradients, and corners are gradients made solid. They're interruptions in the flow. Even the structures we consider naturally angular, like crystals, reveal this pattern when you look closely. Crystals form from repeating patterns of atoms, and some, like quartz or salt, do grow with sharp edges. But those edges exist only under very specific conditions, in isolation, without the erosive forces of the world acting on them. The moment wind, water, or pressure interacts with them, they begin to round off. Their apparent perfection is temporary. If you've ever watched a bar of soap dissolve in water, you've seen this process accelerated. The corners disappear first. The shape collapses inward until what's left is a smooth, curved remnant. It's as if the object is returning to the state it always wanted to be in, shedding the unnecessary effort of maintaining edges. Mathematically, corners are complex. They create discontinuities, points where one set of equations stops working and another begins. In fluid dynamics, for instance, flow around a sharp edge produces turbulence and drag. That means wasted energy. Smooth curves, on the other hand, let air or water glide past effortlessly. Birds, fish, and even seeds have evolved to take advantage of that. The shape of a bird's wing, the curve of a dolphin's body, the streamlined form of a seed pod, all designed by trial and error over millennia to reduce resistance. Every line in nature has been softened by the need to move efficiently. It's no accident that the human heart, lungs and blood vessels are full of curves. Each branch of your arteries and veins splits smoothly, avoiding sudden changes in direction that would cause turbulence. The rounded chambers of the heart allow blood to flow evenly and pressure to distribute gently. Corners would create dead zones, places where flow stagnates or pressure spikes. The geometry of life is quite literally curved for survival. Even our bones follow the same rule. Long bones have rounded ends that fit neatly into sockets. The curves allow rotation and motion without grinding. Sharp edges would break easily or tear the surrounding tissue. Over millions of years, evolution has refined these designs into perfect mechanical harmony. The shapes of our joints are not arbitrary. They are physics made flesh. In human-made systems, we sometimes forget this logic. We build square rooms and rectangular streets because it's efficient for planning, not because it's efficient for nature. Yet even in our own designs, we find ourselves returning to curves when it matters most. Airplanes, cars, ships, all rounded. The shapes that move, that must endure stress or flow, always surrender their corners. The ones that don't move, boxes, walls, crates, can keep them, but only because they're protected from the forces that would wear them down. In the long run, nature's patience outlasts our geometry. The wind will wear away even the hardest edge. Waves will round a coastline no matter how jagged it begins. Time always favours the smooth. On the atomic scale, the same logic plays out in the arrangement of energy fields. Around every particle, forces radiate outward evenly. There are no corners in the electromagnetic field, no abrupt transitions from one direction to another. Everything fades gradually, curves gently. The smoothness of space-time itself, as Einstein described it, reflects that same preference. Even gravity doesn't pull in straight lines. It bends. The universe, at every level, curves around mass and energy as naturally as water curves around a pebble. You could say that the absence of corners is the signature of reality working efficiently. A corner represents imbalance, a place where something is trying to hold more than it can. It's a shape that stores potential energy, waiting to be released. When that energy finds a path, the corner vanishes. The world smooths itself again. There's a reason the earliest life forms were soft. Sharpness requires energy to maintain. Rigid, angular structures can't survive constant motion or collision. Flexibility and curvature, on the other hand, absorb energy, redirect it, and endure. A rounded shell deflects impact. A flexible stem bends with the wind. Even the spiral pattern of DNA is a way to pack complexity efficiently while preserving resilience. Nature designs for survival, and survival depends on managing energy wisely. You can see this principle not only in structure, but in movement. When a predator chases prey, their paths aren't straight lines but arcs. curves and loops. Rivers meander not because they're lost, but because curves distribute erosion evenly. Lightning forks and arcs because electricity too prefers smooth gradients of resistance. Straight lines are abstractions. Curves are reality. If you imagine the universe as a grand network of energy trying to spread evenly through space, corners are the points of inefficiency where flow gets trapped. The universe continually erases them through the slow action of entropy, the tendency toward equilibrium. That's why galaxies swirl, why orbits are circular, why waves roll instead of folding. Every curve is entropy in motion, doing its work quietly and thoroughly. The idea that corners are expensive might sound metaphorical, but it's measurable. Engineers can calculate exactly how much extra energy is required to maintain an angular structure under stress. Architects know that curved arches and domes support more weight than flat beams. Designers of submarines and rockets know that rounded shapes reduce drag. Even in the smallest details, the way water beads on a car's surface, the way light refracts through glass, curves perform better. When we copy nature's curves, our creations last longer, move smoother, and fail less often. It's as though we rediscover, each time, what the universe has known since the beginning, that the most stable way to exist is to round off the edges. But there's also a philosophical side to this. Corners, in a way, represent boundaries, clear divisions between one thing and another. Curves blur those divisions. They connect, merge, and transition. A straight line says, here and not there, but a curve says, here, becoming there. The world, in its deeper physics, doesn't make hard separations. Energy flows continuously, matter exchanges constantly, and boundaries are always softer than they appear. Even the line between living and non-living is less a wall than a gradual gradient. It might be comforting to realize that. The sharpness we build into our world is human-made, a kind of shortcut for understanding. Nature, left alone, erases it. It doesn't draw lines between land and sea, between air and space, between atom and void. It blends them with curves. That blending is what makes everything work together without tearing itself apart. In the end, the preference for smoothness is just another expression of balance. Every system, physical, biological, even social, that tries to maintain sharp divisions eventually wears itself down. Stability comes from distributing tension, and distribution happens most easily when there are no corners for energy to hide in. So when you walk through nature and see how everything curves, the hills, the leaves, the flow of rivers, the arcs of clouds, you're seeing the world's way of conserving effort. You're seeing the universe's instinct for efficiency. Nothing wastes energy holding its edges. Everything relaxes slowly into the form that requires the least to sustain. If you pick up a pebble from a stream and run your thumb over its surface, what you're really feeling is time's patience. Each smooth surface was once a sharp point, now worn away by countless collisions with water, sand, and gravity. Each mark is the story of stress dissolving. The pebble is a physical record of the universe economizing energy, and if you look closely at your own reflection in that stream, you'll see those same curves mirrored back, in the roundness of your pupils, the arcs of your face, the gentle curvature of your shoulders and hands. You too have been shaped by the same laws. Every curve in your body is the result of energy distributed, tension balanced, structure optimized for endurance. You're a living argument against corners. That realization connects everything we've explored so far, from droplets to atoms, from planets to living forms. The roundness of the world isn't an aesthetic coincidence, it's a mathematical and energetic necessity. Wherever forces meet equally, the shape that emerges is smooth. Wherever they don't, corners form, and nature immediately begins to erase them. When you trace a circle, even just with your fingertip in the air, you can feel something satisfying about its completion. It has no start and no end. The motion continues effortlessly, without corners to interrupt it, without resistance or direction to favour. It's not just a line looping back to itself, it's balance made visible. Every point on a circle is the same distance from the centre, and that uniformity carries a strange kind of strength. The circle doesn't need reinforcement. It supports itself by its own symmetry. You can see the logic of circles everywhere, often in places so ordinary that you might not think twice about them. The wheels on a car, the ring of a tree trunk, the swirl of cream in a cup of coffee, all share the same principle. They distribute stress evenly, rotate smoothly, and use energy efficiently. The wheel, for instance, wasn't invented because it was beautiful, though it is. It was invented because it works. It turns effortlessly, maintaining contact with the ground while keeping motion continuous. A square wheel would lurch and jar, a circle glides. The same geometry makes circles fundamental in physics. When an object moves in a circle, it's constantly changing direction. That means it's constantly being pulled inward by a force, what we call centripetal force. On a planetary scale, that force is gravity, keeping worlds in orbit. On a smaller scale, it's the tension in a string swinging a weight. In both cases, the principle is the same. Motion and force are in perfect balance. The object moves without flying away or collapsing inward. That's why orbits are circular, or nearly so. It's the only shape where the gravitational pull from a central body perfectly balances the motion of the object moving around it. Every planet, every moon, every particle circling a nucleus follows that same rule. The universe runs on circles because they're the geometry of steady motion. Even light, which travels in straight lines through space, bends into arcs when it encounters gravity. Around black holes, those arcs can close completely, forming what's called a photon sphere, a region where light itself orbits. The circle, it seems, isn't just a shape we notice in the world. It's embedded in the laws that define it. The power of the circle lies not just in how it looks, but in how it behaves. It's the most stable and efficient way to move, to contain, and to balance. Engineers use circular shapes in gears, turbines, and lenses for exactly this reason. In a circle, every point moves with the same angular speed, meaning there's no wasted motion, no uneven strain. That efficiency is why stars spin, planets orbit, and atoms hum with rotational energy. It's not design, it's inevitability. You can even feel that balance in your own body. Your joints rotate in arcs, not straight lines. When you turn your head or move your arm, your muscles and bones follow circular paths because that's how leverage works best. The round sockets of your shoulders and hips allow that motion, distributing force in every direction equally. Even your heartbeat follows a repeating cycle, a pulse that loops endlessly until it rests. The very rhythm of life is circular. In mathematics, the circle occupies a special place because it connects so many ideas. The number p, the ratio of a circle's circumference to its diameter, appears in equations across every field of science, from the motion of planets to the behavior of waves, from probability to quantum mechanics. It's as if p is the universe's shorthand for continuity, a constant reminder that cycles are built into everything. You can't escape circles even when you move into abstract realms. They appear in the rotation of complex numbers, the oscillation of signals, the periodicity of time. The circle is the geometry of repetition, and repetition is the foundation of existence. When ancient humans first began to observe the skies, they noticed this pattern intuitively. The sun rose and set in a perfect loop. The moon waxed and waned in repeating cycles. The stars moved in circles across the heavens, days, months, seasons, all circular in nature. Time to them was not a straight line, but a wheel, turning endlessly. That perception shaped their myths, their calendars, their sense of reality. To live in harmony with the world meant to understand its circles. The return of dawn, the rotation of crops, the rhythm of tides. Even the earliest temples reflected that belief. Many were built around circular designs. Stonehenge, the ring of Göbekli Tepe, the domes of early civilizations. Circles invited alignment with the heavens, symmetry with the sky. They were not just aesthetic choices, but reflections of a cosmic truth. The universe repeats itself, and we live within that repetition. The circle's strength also lies in its neutrality. It has no beginning or end, no hierarchy of points. Every part of it is equal. That's why it appears again and again as a symbol of unity and wholeness, not because humans decided it should, but because our minds recognize in it the physical shape of balance. When you stare into a circular pattern, a ripple in water, the iris of an eye, the spiral of a shell, your brain finds peace in that symmetry. It's predictability without monotony, motion without chaos. From a physical standpoint, circles are efficient because they minimize perimeter for a given area. That's the same logic that drives surface tension to form spheres. In 2 dimensions, the circle is the most economical way to enclose space. If you have a piece of flexible material and stretch it evenly from a central point, it naturally becomes circular. It's the flat version of the same balance that creates round planets. That principle has practical uses in everything from soap bubbles to city planning. When colonies of bacteria grow on a petri dish, they expand in circles because nutrients spread evenly in all directions. When humans gather around a fire, they form circles because it allows equal access to light and warmth. Even when herds of animals or schools of fish react to threats, they often arrange themselves in circular formations, defensive and efficient. The shape emerges from collective balance, not conscious design. At a deeper level, the circle defines the movement of energy itself. Vibrations, waves, and oscillations, whether of sound, light, or matter, are all expressions of circular motion through time. A wave, if you track it mathematically, is just a circle viewed from the side, its rotation mapped onto a line. Every vibration, every pulse, every heartbeat is a hidden circle unfolding in time rather than space. The universe, in that sense, is built from rotations we experience as rhythm. The circle's presence extends even into quantum mechanics. Particles like electrons possess intrinsic spin, not spin in the macroscopic sense, but a kind of rotational symmetry that gives them angular momentum. That property determines everything about how they interact, from magnetism to chemical bonding. The structure of matter itself depends on the hidden circles within particles. Without spin, the universe as we know it couldn't exist. On cosmic scales, that same property emerges again. Galaxies rotate in vast spirals, bound by gravity but kept in motion by the angular momentum inherited from their formation. Our own Milky Way turns slowly, completing a rotation every 200 million years, its stars moving in enormous arcs that repeat across billions of lifetimes. If you could watch from far enough away, the galaxy would look like a glowing wheel turning in the dark. The repetition of this shape across so many scales suggests that the circle is more than geometry. It's a pattern of organization. Systems that balance forces evenly tend to rotate. Systems that rotate tend to persist. You could think of the circle as the universe's way of sustaining motion without waste. It's the simplest path between order and chaos. Even in abstract systems, economics, ecosystems, biological cycles, the circle reappears. Resources flow, deplete, regenerate, and return. Life grows, decays, and is reborn through the same looping continuity. Energy moves from one form to another but never disappears, completing the endless circuit of transformation. The law of conservation, one of the most fundamental in physics, is circular in nature. Energy neither begins nor ends. It moves through cycles. You can find this same logic in your own experience of time. Every day repeats the last in structure. Light returns, darkness follows, meals, sleep, waking. We often imagine time as a line moving forward, but our lived experience of it is circular. Seasons return, birth and death repeat across generations, the planet spins, the moon circles, the stars rise and set. We exist inside a set of nested circles, each turning within another. And perhaps that's why circular patterns feel instinctively right to us. When we see them, in the swirl of galaxies, the orbit of planets, the design of mandalas, or the ring of a tree, we're seeing something that mirrors our own rhythms. We're tuned to circles because we live inside one. The circle's hidden power, then, is not mystical but mechanical, though its consistency across scales gives it the appearance of something greater. It unites motion and stillness, symmetry and change. It allows things to move endlessly without progressing toward destruction. It's how energy sustains itself. Even when systems fail, they often return to circular states. After an explosion, debris spreads outward in a sphere. After a ripple of disturbance, waves radiate in circles. When gases expand, they do so equally in all directions. Equilibrium, once lost, seeks the circle again. It's the universe's default shape of restoration. In technology, we use circles for the same reasons. The gears in machines, the lenses in cameras, the pipes in plumbing, all around because the shape tolerates pressure, distributes stress, and allows rotation. When you twist a doorknob, spin a wheel, or watch the hands of a clock move, you're relying on the same geometric principle that keeps the moon orbiting the Earth. The circle's strength is in its constancy, and in art, architecture, and design, circles appear whenever the goal is harmony or endurance. The arch of a bridge, the dome of a cathedral, the curve of a violin's body, all serve both form and function. They channel force evenly, reduce tension, and produce resonance. A straight beam holds weight, but a curved dome holds time. It remains standing because every part supports every other part. That's not metaphorical, it's structural physics. When early builders discovered the strength of the arch, they were, in essence, discovering how to use the power of the circle on its side. The same geometry that keeps a planet from collapsing also keeps a ceiling from falling. The curve divides weight into components that push inward and downward simultaneously, finding balance through distribution. The arch doesn't resist gravity, it works with it. That cooperation between form and force is the reason circles endure where corners fail. They don't fight their environment, they adapt, they flow, they balance. The hidden power of the circle lies in that quiet agreement with physics. It doesn't need strength to survive, it needs symmetry. Even sound, which we think of as linear waves, obeys circular principles. When you speak or play a note, the vibration moves outward in expanding spheres of pressure. These sound waves travel equally in every direction until they meet obstacles. Every whisper, every heartbeat, every tone is a pulse of circular energy radiating through air. That's why echoes form concentric patterns and why resonance occurs in circular cavities, like the body of a drum or the chamber of your chest. When you think about it this way, the circle's influence feels inescapable. It defines motion, stability, sound, light, and life. The hidden power isn't hidden at all. It's simply so universal that we stop noticing it. We live surrounded by circles, not just in what we see, but in what we are. You could map your own existence as a set of loops, your breath rising and falling, your heartbeat cycling, your thoughts repeating in familiar rhythms. Even your sleep follows a circular pattern. Phases of deep and light rest, returning through the night. Your body, your mind, your world, all turning gently inside each other's circles. And the longer you observe the world this way, the more you see that the circle is not a boundary, but a path. Everything that moves, grows, or evolves does so in cycles. The planets turn, the weather shifts, life renews itself. The shape of endurance is circular. The universe uses the circle not as decoration, but as its simplest method of continuation. For all the calm symmetry we've seen in the universe, there are plenty of moments when things don't follow the rule. You can find them in the cragged face of an asteroid, the uneven outline of a mountain, the lopsided pull of a galaxy. Not everything is smooth, not everything becomes round. The universe loves balance, but it also allows chaos, and that tension between the two, between what should be round and what resists, tells an even deeper story about how nature works. We often think of roundness as perfection, and in a mathematical sense it is. A sphere minimizes energy, a circle repeats endlessly without flaw. But real matter doesn't live in equations. It exists in collisions, pressures, temperatures, and timescales. The forces that shape the world don't act in isolation. They interfere, compete, and sometimes overwhelm each other. The result is a universe full of near rounds, shapes that almost achieved equilibrium but fell short because other rules intervened. If you look at small bodies in space, asteroids, comets, fragments of shattered moons, you'll notice they're rarely spherical. They tumble through the void in awkward shapes, sometimes looking like potatoes, sometimes like jagged stones. The reason is simple. They're too small for gravity to take full control. Their self-gravity isn't strong enough to pull them into a sphere. Instead, their own internal strength, the rigidity of their rock or ice, holds them in whatever shape they happen to form. There's a threshold known to planetary scientists called the hydrostatic equilibrium limit. When an object reaches a certain mass, its own gravity becomes strong enough to overcome the mechanical strength of its material. That's when it rounds out. Anything below that threshold stays irregular, because the force that would make it round simply isn't strong enough. You can think of it as gravity's jurisdiction. Beyond a certain size, gravity rules. Below it, solidity wins. That's why large planets and moons are spherical, while smaller asteroids are not. Take Vesta, for instance, one of the largest objects in the asteroid belt. It's massive enough to start rounding itself, but not enough to finish the job. Its equator bulges, its poles are rough. It's a world caught between shapes, too big to be simple, too small to be smooth. When NASA's Dawn spacecraft visited Vesta and Ceres, it sent back images of worlds that looked imperfect, scarred, oddly proportioned. And yet, even in those imperfections, you could see gravity trying. The outlines were softened, the deepest craters rounded at the edges, the ridges slumping over time. Gravity doesn't stop pulling just because it can't win outright. It keeps working, endlessly wearing down the sharpness, even if the process takes billions of years. On Earth, you can see the same competition between forces. The planet as a whole is round, yes, but its surface is full of irregularities. Mountains rise, trenches sink, continents shift. Those distortions exist because other forces, tectonics, heat, erosion, act locally, pushing and pulling against gravity's smoothing hand. Over time, gravity always tries to restore equilibrium, dragging everything back toward the center, but the process is ongoing. The Earth we walk on is a round shape temporarily disguised by activity. Even the largest round objects in the universe aren't perfectly round. The Earth itself bulges slightly at the equator because of its rotation. That spin creates centrifugal force, which pushes outward against gravity. The faster a planet spins, the more pronounced that bulge becomes. Jupiter, for example, rotates once every 10 hours, and its equatorial diameter is more than 10,000 kilometers greater than the distance between its poles. It's still roughly spherical, but the deviation is measurable. An oblate spheroid, not a perfect sphere. The same principle applies to stars. Rapidly spinning stars flatten at their poles and expand at their equators. Some are so distorted that they resemble squashed balloons. Others throw off material along their equators, forming rings or disks of gas. The faster the spin, the harder it becomes to maintain perfect roundness. The universe, it turns out, pays a price for speed. Rotation isn't the only culprit. External forces, impacts, tides, and magnetic fields all create a symmetry. When two celestial bodies interact, their mutual gravity can stretch them into ellipsoids or teardrop shapes. This is called tidal deformation, and it happens whenever objects orbit closely. The moon, for example, is slightly stretched toward Earth, just as Earth itself bulges toward the moon. That's what drives our tides, the constant rhythmic flexing of our planet under lunar pull. In extreme cases like the moons of Jupiter, tidal forces can heat entire worlds from within. Io, one of Jupiter's largest moons, is constantly being pulled and squeezed by the giant planet's gravity. The friction from that stretching keeps its interior molten, driving volcanoes that erupt continuously. Io is roughly spherical, but its surface is far from smooth. It's a world of distortion and motion, proof that balance can coexist with chaos. Even galaxies vast beyond imagining carry their own imperfections. Spiral galaxies look symmetrical from a distance, but closer observation reveals uneven arms, warped disks, and lopsided distributions of stars. These irregularities arise from collisions and gravitational interactions with neighbouring galaxies. The Milky Way itself bears scars of such encounters. Streams of stars torn from other systems, loops of gas stretching into intergalactic space. On cosmic scales, even the grandest circles wobble. When you move down to the microscopic world, irregularity continues. Molecules, for example, are often asymmetrical because atoms form bonds at specific angles. Those angles depend on the arrangement of electrons, which follow quantum rules that don't care about aesthetic symmetry. The result is a universe where perfect geometry is an exception, not the norm. Balance is a direction things move toward, not a state they permanently inhabit. This makes sense when you remember that energy drives change. Perfect symmetry, perfect roundness, perfect equilibrium, those are conditions of rest. But the universe is not at rest. It's dynamic, expanding, colliding, transforming. Every process that builds structure also disturbs symmetry. Roundness may be the destination, but motion is the journey, and motion always leaves marks. You can see the same idea in biology. Living things rarely display perfect circles or spheres. Cells are roughly round, but they deform as they move or divide. Eggs are curved but asymmetrical. Even the human eye, which we imagine as a perfect globe, is slightly irregular. The cornea and lens introduce subtle distortions that help focus light. Our bodies, our organs, our cells, all show evidence of life pushing against equilibrium. That's because living systems depend on gradients, differences in pressure, concentration, temperature. Those differences drive movement, metabolism, and growth. A perfectly balanced system wouldn't evolve, wouldn't think, wouldn't live. The same asymmetry that distorts the ideal shape is what allows complexity to exist. Roundness represents rest, but life thrives in imbalance. On a deeper level, this imperfection reveals something essential about nature's design. The universe seeks equilibrium but never quite reaches it. Every round thing bears evidence of that struggle. Even the most polished pearl has a tiny irregularity, a point of origin around which its symmetry formed. The moon's surface, viewed from afar, looks like a smooth sphere, but up close it's scarred by craters, ridges, and valleys. Each mark is history written in topology: impacts, eruptions, cooling, collapse. The perfect curve, interrupted again and again. The same is true for human creations. We can draw a circle on paper, but even with the steadiest hand, magnify it enough, and you'll see the imperfections. Engineers can design a spherical lens with extreme precision, yet even there, at the atomic level, the glass contains irregularities. Absolute roundness exists only in mathematics, not in matter. The physical world allows only approximations. And maybe that's not a flaw, but a necessity. Imperfection introduces variation, and variation allows resilience. If everything were perfectly round, perfectly balanced, nothing would change. The universe would freeze in symmetry, lifeless and static. The small deviations, the bulges, dents, ripples, and asymmetries create movement, difference, and possibility. They're the reason planets spin, climates shift, and species adapt. You can even think of imperfection as the universe's way of maintaining interest. Without it, there would be no evolution, no narrative, no time. Every dent in the roundness is a sign of activity, a trace of energy still flowing. The universe refuses to be perfectly round because it refuses to stop. From a physical standpoint, the forces that disrupt roundness are as important as those that create it. Pressure, rotation, magnetism, collision. These are the agents of change. They stretch, distort, and occasionally destroy, but through that destruction, new forms emerge. Every cratered asteroid, every misshapen moon, every uneven planet is evidence of the same balance-seeking process still unfolding. Roundness isn't a permanent state, it's a tendency constantly negotiated. That idea holds true even for you. Your heart beats in rhythm but not perfectly. Your breathing cycles but with small variations. Those imperfections aren't malfunctions, they're adaptations. The slight irregularities in rhythm allow flexibility. A perfectly regular heartbeat would, paradoxically, be fragile. In both physics and biology, variability sustains stability. The universe, then, is a compromise between perfection and disruption. Its beauty lies not in flawless symmetry, but in the persistence of symmetry under stress. The fact that things can almost become round, despite all the forces pulling them apart, is what makes the pattern remarkable. Roundness is not guaranteed, it's earned. Even light, which we often imagine as pure and uniform, is distorted as it travels. Gravity bends it, gas clouds scatter it, magnetic fields twist it. Yet, despite all that interference, the pattern holds. Circular halos around stars, arcs of light around galaxies, waves spreading in spherical fronts. The perfection remains visible, even when imperfectly achieved. Astronomers use that very imperfection to learn about the universe. When light from a distant galaxy passes by a massive object on its way to us, the gravity of that object bends the light into a ring or arc. It's called gravitational lensing, and it's never perfectly symmetrical. The distortions reveal how mass is distributed, where dark matter hides, how far and how fast the light has travelled. Imperfect circles become a tool for understanding the invisible. You could say that every irregular shape, every broken symmetry, carries information. Perfection is silent. Imperfection speaks. The roughness of a surface tells you how it was formed. The unevenness of a planet's field reveals what's inside. Even the asymmetry of a living body carries history. Injuries healed, adaptations made, growth patterns followed. To refuse perfect roundness is not to reject order, but to express experience. In that sense, the universe's refusal to be perfectly round is also its way of remembering. Every imperfection is a memory of motion, a record of interaction. The roundness shows what gravity intended. The deviations show what time has done. When you look at something irregular, a jagged stone, a wrinkled leaf, a cratered moon, you're seeing balance interrupted, but not destroyed. You're seeing the dialogue between creation and disturbance, between symmetry and entropy. And that dialogue never ends. The rough edges today will be smoother tomorrow, and the smooth ones will be broken again later. Roundness and irregularity chase each other endlessly through time. Even in the human mind, perfection and disruption coexist. We strive for balance, for simplicity, for roundness in thought, and yet it's our irregularities that make us capable of change. A perfectly ordered mind would have no curiosity, no creativity, no doubt. The same restlessness that pulls planets out of perfect spheres is what drives us to ask why. It's tempting to wish the universe was smoother, that everything would settle into balance. But if it did, there would be nothing left to see. The round things draw our eyes because they stand out against the roughness. The roughness gives them meaning. The two depend on each other. When things refuse to be round, They remind us that balance is not the absence of conflict, but the continuation of it. Roundness is what happens when tension finds temporary peace, but tension itself is what keeps the world alive. The universe is full of shapes that have not yet relaxed, still stretching, still colliding, still reshaping themselves toward roundness without ever fully arriving. And as that endless process continues, the irregular shapes create patterns of their own. Waves, spirals, and oscillations that move through space like echoes of the original symmetry. Even in their refusal, they carry the trace of the circle. The arc is still there, hidden within the broken line. If you close your eyes right now, before anything else, just listen to the air around you. The quiet hum of an appliance, the soft tick of a clock, the faint rush of distant traffic, maybe the wind if your window's open. Each sound, whether near or far, arrives in gentle waves that wrap around you, filling the space rather than slicing through it. Sound doesn't move in lines or corners, it travels outward in expanding spheres. Every word, every note, every whisper begins as a vibration that curves. It's easy to think of sound as something linear, as if it moves from a source directly to your ear, but that's only how we imagine it. In reality, when something makes a sound, when a string vibrates, or air moves through a pipe, or your vocal cords tremble, it pushes on the air in all directions at once. The molecules nearby compress and then relax, passing that disturbance outward like ripples in a pond, except those ripples don't stay flat. They expand in 3 dimensions, forming spheres of pressure that grow and fade with distance. Each time you speak, you're surrounded by these invisible spheres of motion. The air in front of you vibrates, the molecules bump into their neighbours, and the wave travels onward, round and complete. The sound doesn't choose a path. It radiates evenly, unless the space itself redirects it. Walls reflecting, corners diffusing, surfaces absorbing. But in its purest form, sound is round. The physics behind it is straightforward. When you pluck a string or strike a drum, the surface moves back and forth, creating alternating regions of high and low pressure in the air. These variations travel outward at a fixed speed, the speed of sound, and because they spread equally in all directions, their shape at any given moment is spherical. If you could freeze time and see sound the way you see light, you'd watch expanding shells of compression racing away from their source like transparent bubbles, overlapping and merging as they fill the room. Every sound you've ever heard began this way. A laugh, a drop of water, a passing car. Each sent countless little waves expanding outward, each one curving perfectly until it dissipated into silence. Even in silence, the air is never completely still. Tiny vibrations move through it constantly, shaped into curves you can't feel but that never stop existing. In open air, these waves travel freely. But the moment they encounter obstacles, the shapes begin to change. Hard surfaces reflect them, sending the wave back along a curved path. That's how echoes form. The returning waves bounce off walls, mountains, or canyon faces, and their roundness allows them to keep their structure even as they change direction. If you've ever called out in an empty hall or canyon, the echo you heard was your own sound completing a full circle, leaving you and coming back, softened by distance but still round in its expansion. In smaller spaces, sound behaves differently. The waves interfere with each other, overlapping in patterns of reinforcement and cancellation. These standing waves create zones where sound seems louder or quieter, as if the air itself were carved into invisible shapes. And yet, even here, the underlying structure remains curved. Every interaction of sound, every echo or resonance follows the geometry of waves, the endless rise and fall that traces circles through time and space. Music, at its foundation, is simply the organization of those curves. Each note corresponds to a frequency, a certain number of vibrations per second. The higher the frequency, the shorter the wavelength, the tighter the circle of motion. When multiple frequencies combine, they create interference patterns that our brains interpret as harmony, rhythm, or melody. What we hear as sound is the meeting point of physics and perception, a translation of circular vibrations into emotion and thought. If you've ever watched a slow-motion video of a drum being struck, you can see the surface flexing, its center dipping and rebounding as concentric rings of motion spread outward. That's sound in its most visible form, the surface moving in perfect symmetry, transferring energy to the air in expanding spheres. The drum doesn't produce corners or lines, it produces circles. The same happens in your throat when you speak. Your vocal cords are folds of tissue that open and close rapidly, creating pulses of air pressure that move outward. Those pulses are shaped by your mouth and nasal cavities, forming resonant chambers that enhance certain frequencies and soften others. When you hum or sing, you're tuning those chambers, shifting their shapes slightly to change which circular vibrations are amplified. The process is mechanical, but the result feels deeply personal. Every voice is unique because every set of resonating shapes, throat, mouth, chest, is unique. Each human sound is a complex mixture of spherical waves, layered and reshaped before they ever leave the body. Sound behaves differently in different materials, but the principle remains the same. In water, where molecules are closer together, sound travels faster and farther, but it still moves in waves that expand in circles. In solid materials, vibrations travel even more efficiently, sometimes hundreds of times faster than in air. A knock on a metal pipe or the rumble of a train through rails, both send spherical pressure waves through dense matter. The shape never changes, only the speed. Even silence, in a way, depends on these curves. The absence of sound is simply the balance of air pressure restored. No neck compression, no expansion, just evenness in all directions. Silence isn't the lack of movement, it's the equality of it. The calm after a sound is the air remembering its equilibrium. The roundness of sound extends to how we perceive it. Our ears are themselves shaped to receive these spherical waves efficiently. The outer ear, the pinna, curves and folds in ways that capture sound from different angles and focus it toward the eardrum. That curvature helps us determine direction and distance. A flat surface wouldn't work as well. It would distort or block certain frequencies. The rounded structure lets waves enter smoothly, preserving the information encoded in their shape. Inside the ear, the roundness continues. The eardrum, a thin circular membrane, vibrates in response to incoming pressure waves. Those vibrations pass through the three smallest bones in your body, the hammer, anvil, and stirrup, each one designed with subtle curves that transmit motion efficiently. They deliver the vibrations to the cochlea, a spiral-shaped organ filled with fluid and lined with thousands of tiny hair cells. As the vibrations move through that fluid, they travel in waves that curl around the spiral, stimulating different cells depending on frequency. The cochlea literally unwinds sound in circular motion, translating spherical pressure into patterns your brain can interpret. Every note of music, every syllable of speech, every sound you've ever heard was once a circle, passed through a spiral, and reinterpreted as sensation. The architecture of hearing itself is round because sound is round. There's a quiet coherence to that design. The shape of the organ matches the shape of the energy it receives. You could almost say that we're built to understand the geometry of the world through sound. Long before language, long before writing, our ancestors recognized meaning in the rhythm of waves, the rustle of leaves, the approach of thunder, the cry of an animal. Sound taught awareness long before sight could confirm it. And because sound expands spherically, it connects us in all directions. When you speak, your voice doesn't travel toward one listener. It moves outward equally, filling the air. Even if no one is near, your sound touches walls, air, surfaces, leaves, dust. It becomes part of the world's motion. You can't contain sound the way you can contain light. It wraps around obstacles, diffracts through openings, bends around corners. It reaches places you can't see. The roundness of sound makes it democratic. It belongs to everyone within reach of its waves. In nature, this round motion of vibration governs everything from the chirping of crickets to the calls of whales. The larger the creature, the longer the wavelengths it produces. Whales, singing deep in the ocean, send sounds that can travel for hundreds of kilometers, spherical waves that fill entire seas. The geometry doesn't change with scale. Whether it's a bee's hum or a whale's song, sound always moves as an expanding sphere. The same physics governs instruments. A flute's tone, a violin's resonance, the echo inside a cathedral, all shaped by how air vibrates and reflects in rounded spaces. That's why circular architecture, domes and halls, produces such remarkable acoustics. In a dome, sound reflects uniformly, reinforcing itself evenly. The curve focuses and blends vibrations without abrupt reflections, letting tones linger. Ancient builders didn't have acoustic theory, but they understood through experience that round spaces amplify harmony. Even today, when architects design concert halls, they use this knowledge. The curvature of walls and ceilings ensures that sound travels smoothly, reaching every listener without distortion. Straight angles scatter or absorb it unevenly. Curves share it. The best sound, like the best motion, happens in shapes that flow. The universality of these curves extends into the mathematics of waves. A sound wave is described by sine and cosine functions, pure circular motion projected through time. If you imagine a point moving around a circle at constant speed and you record its position along one axis, you get a sine wave. That's what a pure tone looks like. Every note you hear, every vibration in the air is fundamentally the trace of circular motion. When several waves combine, their interference patterns create the complex shapes of voices and music, but at their foundation, they're all rotations. Circles turned sideways into time. In this sense, sound isn't just round in space, it's round in behavior. Each vibration repeats, cycles, oscillates. Sound is time measured in circles, energy looping again and again until it fades. Even when it seems to end, the air continues to move for a moment longer, tiny residual ripples completing their final rotations. The fade of a note, the quiet after a word. Those are circles dissolving into equilibrium. If you could visualize all the sounds happening around you at once, every vibration from the street outside, the hum of the refrigerator, your own breathing, you'd see a complex web of overlapping spheres, intersecting and merging in constant motion. Each wave curves through the others, sometimes cancelling, sometimes reinforcing, creating the ever-changing texture of noise we call the environment. Silence is never truly empty. It's simply the balance point where all these circles overlap evenly. Even earthquakes, those deep sounds of the earth itself, follow the same geometry. Seismic waves spread outward from their source in spheres, passing through rock, water, and air. The ground's shaking, the rumble you hear, the patterns scientists measure. All are manifestations of circular energy expanding through matter. The same laws that shape the whisper of your breath shape the planet's voice. If you stretch this idea outward to the scale of the cosmos, the first sound in the universe was round too. In the early moments after the Big Bang, when the universe was dense and hot, waves of pressure moved through the plasma of particles, sound waves in the fabric of space itself. They expanded outward in all directions, leaving behind faint imprints that we can still detect today as the cosmic microwave background. The earliest vibrations of existence were spherical. The universe began by ringing like a bell. That echo remains, stretched and softened by billions of years of expansion, but still visible as subtle ripples in temperature and density across the sky. Scientists map those ripples to understand how galaxies formed, how matter distributed itself, how the first roundness of sound shaped the large-scale structure of everything. Even the stars above you owe their arrangement to ancient vibrations that once moved through space as spherical waves. The next time you listen to something, a song, a conversation, the rain outside, it might be worth remembering that each sound is a continuation of that same ancient geometry. You are, in a sense, surrounded by echoes of the universe's first vibrations. The air that carries your voice is following the same rule that carried the first sound through space, and though we often treat hearing as a passive sense, it's actually an act of participation. When sound reaches you, your own body becomes part of the wave's motion. The eardrum vibrates in time with the air, the bones move in sequence, the fluid inside your cochlea ripples in circles. You don't just perceive sound, you temporarily share its shape. For an instant, the geometry of the wave becomes the geometry of you. That's one of the reasons sound feels intimate in ways that sight or touch do not. It surrounds rather than targets. It passes through walls, through bodies, through space itself. When you listen, you're not observing from the outside. You're inside the movement, immersed in it. The roundness of sound makes it inclusive. It gathers everything within reach into a single continuous vibration, and that inclusiveness extends beyond the physical. When people sing together or listen to music, their breathing synchronizes, their heart rates align, their neural rhythms start to match. The shared sound becomes a shared pattern of motion. It's a collective geometry, circular waves connecting individuals into one rhythmic field. The harmony isn't just heard, it's lived. Even when sound distorts or breaks apart, when noise drowns melody or echoes blur words, the roundness remains beneath it all. The chaos of overlapping waves still obeys the same rule: expansion, curvature, return. Noise is just too many circles at once. If you take all this together, the physics, the biology, the emotion, you can start to see how deeply sound embodies the same roundness that shapes planets, droplets, and atoms. Each vibration is a small, temporary universe of symmetry. Each note, each word, each ambient hum is a brief balance between compression and release, tension and rest, energy and silence. And as you listen to those sounds, whether they come from the world around you or from within yourself, you're hearing the continuation of that universal pattern, energy finding the most efficient way to move. It's the same reason stars form spheres, why planets orbit, why raindrops round themselves, and why music feels whole when it resolves. Sound is simply the circle made audible, and as you let that thought settle, you might begin to sense how much of life's order, even beyond sound, arises from the same pattern. The curves of voices and vibrations extend outward into everything humans create: art, movement, architecture, all shaped by the same physical preference for balance and flow. Because whether it's a star singing in radio waves, a string vibrating in air, or a heart beating quietly in the dark, everything in the universe speaks in circles, and every sound is the roundness of energy reminding matter how to move. You don't have to be an astronomer, an architect, or a physicist to feel something special about a circle. People have been drawn to them since long before we had words to explain why. The first humans traced circles in the dirt, stacked stones in rings, carved wheels and bowls and beads. When they painted on cave walls, they drew suns and moons, loops and spirals, round shapes that echoed something they saw in the world and something they already understood inside themselves. Our fascination with circles isn't a recent invention. It's one of the oldest patterns our minds recognize. You can see it in every culture, every time period, every corner of history. We build with them, worship through them, tell time by them, and find comfort in them. The circle, more than any other shape, feels complete to us. And that feeling, that instinctive response, has roots far deeper than symbolism. It's written into how our eyes see, how our brains process balance, and how our bodies move. When you see a circle, your mind responds differently than it does to a square or triangle. Neuroscientists studying visual perception have found that humans are naturally drawn to curves. Our eyes move more smoothly along them. Sharp angles trigger activity in parts of the brain associated with alertness, and even mild anxiety, while rounded forms activate areas linked to pleasure and calm. The reaction is measurable. We literally feel more at ease when we look at curved shapes. That response makes sense in evolutionary terms. In nature, sharp edges often signal danger. Thorns, teeth, rocks, sudden drops. Rounded forms, by contrast, suggested safety. Fruits, faces, horizons, the steady curvature of a mother's arm. Our visual systems learn to associate curves with gentleness, predictability, continuity. The circle became a visual shorthand for security. You can see this reflected in the design of objects throughout human history. Tools, containers, and ornaments almost always include curves. Even the earliest pottery was round, not because it was easier to make that way. Shaping clay into perfect symmetry without machinery is difficult, but because the result functioned better. A bowl holds liquid efficiently. A rounded vessel resists cracking under pressure. The curve spreads stress evenly. Long before people understood stress distribution, they understood it through touch. The wheel, often described as humanity's first great mechanical invention, is nothing more than a circle made useful. Its power lies in its geometry, continuous motion with minimal resistance. A wheel turns because every point on its rim is the same distance from its center, ensuring uniform movement. That same logic applies to pulleys, gears, and clocks. When we learn to build with circles, we learn to harness balance itself. But the wheel wasn't just a tool for movement. It also became a symbol of time and return. The ancients watched the heavens and saw everything moving in circles. The sun across the sky, the moon through its phases, the stars around the pole. They mapped these motions into cycles, days, months, years, and built their lives around them. The idea of eternity, of continuity without beginning or end, was embodied in the shape of the circle. In many early civilizations, circular structures were sacred. Stonehenge in England, Nabta Playa in Egypt, the medicine wheels of North America, the stone circles of Senegal, all shared the same design principle: symmetry radiating from a center. These places aligned with the sun or stars, connecting human life to celestial rhythms. Standing in the middle of such a space, a person could feel surrounded, enclosed yet free, part of a pattern too large to see in full. The circle became not just a symbol, but a physical experience of belonging to the universe. The architectural preference for circles never disappeared. Domes, arches, and rotundas dominate sacred and civic buildings across cultures. The Pantheon in Rome, the Hagia Sophia in Istanbul, the temples of India and China, all employ the circle to evoke harmony and balance. Even modern observatories and planetariums echo that same impulse. We step into round spaces to contemplate the infinite, perhaps because the shape feels closer to the universe itself. Psychologists who study human preferences for shapes have suggested that circles satisfy a deep cognitive desire for completion. The eye can follow a circle without interruption. There's no corner, no place where the line stops and demands redirection. The motion is continuous, unbroken, and therefore soothing. Our brains, built to predict motion and outcome, find satisfaction in that continuity. The circle resolves tension by never forcing a decision. That same satisfaction appears in music and speech. Rhythms loop, melodies resolve by returning to familiar notes, stories circle back to their beginnings. Even conversation often follows circular patterns. We begin, explore, digress, and return. The structure of our communication mirrors the shape that calms us. Language itself reflects our attachment to circles. We speak of life coming full circle, of cycles, of revolutions both literal and figurative. We talk about circles of friends, circles of trust, circles of influence. Each phrase implies inclusion and continuity, a bounded space that still allows movement. We use circles as metaphors for connection because that's how we feel when we're safe, connected without trapped, enclosed without confined. From a cultural standpoint, circles have represented wholeness and unity for millennia. In Hindu and Buddhist traditions, mandalas, intricate circular patterns, are used for meditation, symbolizing the cosmos and the mind as reflections of each other. The act of drawing or observing a mandala quiets the brain by engaging its love for symmetry and repetition. In ancient Greece, philosophers saw the circle as the ideal form, the only shape that could represent divine perfection. Plato called the circle the most beautiful of shapes, believing it mirrored the eternal harmony of the heavens. Even in science, we once measured perfection through circles. When Copernicus and later Kepler studied planetary motion, they initially assumed that planets must move in perfect circles. The idea that celestial motion could be anything else seemed almost wrong. When Kepler discovered that orbits were ellipses, slightly stretched circles, it was considered a revelation not just of astronomy but of philosophy. The universe, it turned out, wasn't perfectly round, only approximately so. That small imperfection made it real. Still, our preference for circular order remained. From the gears in a watch to the structure of an atom, from the rings of a tree to the design of a city's roundabout, we keep returning to the same geometry. Perhaps we can't help it. The circle is efficient, it works, it embodies balance without rigidity. Even our technology, from satellites orbiting Earth to the circular icons on digital screens, continues this ancient affection. There's also something deeply personal about roundness. We find it in ourselves. The shape of the pupil, the curvature of the skull, the arc of a smile, all soft, continuous lines. The human body contains very few sharp angles. That's why we instinctively associate roundness with warmth, comfort, and life. When we design things meant to feel friendly or safe, we round their edges. The casing of a phone, the handle of a cup, the corners of furniture. Designers know what evolution already taught us. Curves invite, corners repel. Even our sense of beauty follows the same pattern. Studies of facial perception show that people consistently prefer symmetry and gentle curvature. A perfectly circular pupil, balanced features, softly rounded outlines. These trigger positive emotional responses. The same neural mechanisms that recognize a safe fruit or a kind expression respond to circular geometry in everything else. The aesthetic and the instinctive merge. This affinity extends into motion as well. We draw circles absent-mindedly, trace rings on tabletops, spin objects in our hands. Children play with hoops and balls long before they can understand geometry. The pleasure of circular movement, rolling, spinning, turning, is universal. It's built into our balance systems, into the semicircular canals of the inner ear that sense rotation. Our very sense of orientation depends on circles. The roundness of sound, which moves through air as spherical waves, may also contribute to this preference. We live immersed in circular vibrations. Every word and song we hear reinforces the experience of curves and continuity. To love circles, in a way, is to love resonance itself, the feeling that energy can flow without obstruction. When you look at the natural world, you can see countless reasons why our brains learn to favour the circle. The sun and moon, perfectly curved against the sky, became the most reliable markers of time. The horizon itself curves gently, reminding us of the planet beneath our feet. The droplets of rain, the fruits of trees, the ripples in water, each reinforces the same visual comfort. The world taught us to find calm in curvature. There's also a practical side. Circular motion underlies survival, the cycle of day and night, of growth and decay, of seasons returning, all allowed life to predict, to plan, to adapt. In an unpredictable world, cycles offered reassurance. To early humans, seeing the sun rise again was evidence of order. The circle was the symbol of that promise. What leaves will return. That association persists today, even if we rarely articulate it. We find comfort in routines, in loops of behaviour that repeat. We design our calendars, our rituals, our traditions in cycles. Holidays return, birthdays come again, clocks loop through hours. These circular patterns don't just organise time, they mirror the rhythms of our own biology, the pulse, the breath, the sleep-wake cycle. When life feels too linear, too uncertain, we instinctively seek circles to bring it back into rhythm. Even in modern architecture and art, where sharpness and abstraction often dominate, circles still appear as anchors of harmony. The curve of a bridge, the arc of a skyline, the round window of a chapel, all restore softness where lines threaten to overwhelm. The presence of a curve breaks monotony and reminds us of the natural balance the world prefers. On an emotional level, the circle carries meanings that words often fail to express. It represents return, inclusion, continuity, forgiveness. To make a circle is to close a gap, to create unity from separation. In many cultures, people stand in circles to make decisions or share stories. The shape ensures equality. No head, no tail, no hierarchy. Each person sees every other person directly. The geometry itself enforces connection. That geometry even governs how we experience relationships. Bonds that last are cyclical. Patterns of approach and withdrawal, giving and receiving, conflict and resolution. A relationship that never loops back to understanding breaks. One that turns endlessly, adapting, survives. The human heart itself models this. It contracts, expands, rests, and repeats. Love, both literally and figuratively, is circular. Perhaps the most profound example of our love for circles lies in how we define home. When we speak of feeling centered, grounded, whole, those metaphors come from geometry. To be centered means to occupy a balanced point within a surrounding curve. Home feels circular because it encloses us without confining us, just as a circle encloses space without walls. It's a boundary of comfort rather than restriction. The circle also appears in how we express memory. We revisit moments in thought, loop back to old feelings, replay conversations in our minds. The mind's tendency to circle back, to review and reflect, is part of its process of understanding. Even our dreams, which often repeat themes or images, follow this cyclical structure. We live through time, but we think in loops. And in our sciences, circles persist as tools of understanding. We describe atomic orbitals, planetary systems, ecosystems, feedback loops, cycles of matter and energy. Every closed process that sustains itself forms a circle in principle, even if not in shape. The nitrogen cycle, the carbon cycle, the water cycle, all are circular motions of transformation. Life itself depends on returning to where it began. Our fascination with circles, then, is both physical and psychological. We respond to them because they represent the balance we seek in everything. Motion without chaos, structure without constraint, continuity without stagnation. The circle is what happens when energy finds a steady rhythm. It's a shape of peace, but also of persistence. You can feel that balance most clearly when you watch something in orbit. A moon circling a planet circling a star. There's no violence in that motion, no waste. Just harmony between forces, each held in check by the other. The pull inward and the motion outward balancing perfectly. The same balance, scaled down, exists in every rotation of a wheel, every beat of a drum, every pulse of blood through the body. The geometry repeats because it works. And yet, even as we find comfort in circles, we never stop trying to reach beyond them. Every journey begins with a departure from the loop, a straight line extending outward, searching for something new. But sooner or later we turn back, closing the circle again. The love we have for this shape isn't just about stability, it's about return. The circle doesn't trap us. It gives us a place to come back to after exploration. That's why, no matter how advanced our technologies become or how abstract our art grows, circles remain at the core of our creations. They appear in everything from the interface of a phone to the orbit of satellites, from the rings of data storage devices to the circular accelerators that probe the smallest particles. Even in our most futuristic inventions, the circle endures, quietly doing what it always has, connecting motion, balance, and meaning in one seamless form. And as we continue tracing these circles through thought and technology, through biology and emotion, we keep rediscovering the same truth. We love circles because the universe does. They are the shape of rest and of motion, of stillness and of change, of beginning and of return. To follow a circle is to follow the same rhythm that runs through all things, and that rhythm, subtle and constant, carries us onward, not to an end, but to the next curve waiting beyond sight, where the same roundness reappears again in a different form. When you lift your eyes to the sky, you're seeing circles everywhere, whether you realize it or not. Some are obvious: the sun, the moon, the halo of a planet seen through a telescope. Others are hidden: the invisible paths along which the planets travel, the arcs traced by stars as the Earth turns, the circular movement of air that forms the patterns of weather. The sky, for all its apparent vastness and chaos, is built on roundness. Every motion we see up there is the result of one thing circling another, endlessly. Long before science could explain it, humans noticed this. They saw the sun rise, curve overhead, and set again in the west, repeating the pattern each day. They watched the moon wax and wane in a precise rhythm. They traced the slow looping of stars and constellations around a fixed point in the north, the point we now call the celestial pole. Without instruments or equations, early observers already understood the sky as circular. Time itself was a rotation. The ancient world was filled with skywatchers who built their understanding of the universe around that motion. From the standing stones of Europe to the ziggurats of Mesopotamia, from the pyramids of Egypt to the observatories of the Maya, people aligned their structures to the heavens. They marked solstices, equinoxes, and lunar phases by observing where circles began and ended. The circular paths of the sky became their first calendars. They didn't see the world as a straight line from past to future, but as a turning wheel, light returning, seasons repeating, celestial patterns coming full circle. To them, the circle in the sky was more than geometry. It was a rhythm of existence. The heavens were not random, they were ordered, predictable, divine. The roundness of the sun and moon seemed like the universe's own signature, a symbol of perfection beyond human reach. And in a way, they weren't wrong. The roundness of celestial bodies isn't an illusion. It's the natural outcome of the forces that shape them. Take the sun. A star like ours exists in balance between two opposing pressures: gravity pulling inward and radiation pushing outward. The inward pull tries to collapse the star under its own mass, while the outward pressure from nuclear fusion tries to expand it. The point where those two forces meet defines the star's surface, and because the pressures are equal in all directions, the result is a perfect sphere. The sun is not just round by chance, it's round because that's the shape where its competing forces find peace. When you see it rise above the horizon, you're witnessing a cross-section of that equilibrium. It looks like a simple glowing disk, but in reality it's an immense sphere of plasma held together by the same geometry that governs every planet, drop and atom. Its roundness is gravity made visible, balance given form. The moon follows the same rule, though in a gentler way. Its round shape was carved over billions of years as its molten surface cooled and gravity drew it into equilibrium. What you see now is not a perfect sphere. It's slightly flattened and covered in scars from impacts, but its overall form still follows the same logic. The moon is a circle because it can't be anything else. Its own weight has rounded it, smoothing out any irregularities left from its violent birth. From our perspective on Earth, both the sun and the moon appear as nearly perfect circles in the sky. So perfect, in fact, that their apparent sizes are almost identical. That coincidence gives rise to one of nature's most striking phenomena, the solar eclipse. When the moon passes directly in front of the sun, their disks align so precisely that one circle covers another. For a few minutes, day turns to night, and a ring of light, the solar corona, flares around the darkened moon. It's as if the universe momentarily reveals its geometry to us, two perfect circles overlapping in impossible harmony. It's no wonder ancient cultures saw eclipses as sacred events. To witness one is to see celestial mechanics at their purest, round bodies moving in precise paths, their motions synchronized across millions of kilometers. The eclipse reminds us that even the sky's most mysterious events obey the same simple rule: balance between motion and gravity, circle upon circle. But the circularity of the sky goes deeper than the shapes of the sun and moon. The earth itself spins, creating the illusion of the heavens turning around us. Each night the stars appear to wheel across the sky in great arcs, rising in the east and setting in the west. Over hours, constellations shift their positions, tracing slow, predictable circles. If you take a long exposure photograph of the night sky, you'll see it clearly. Stars forming concentric trails around a single still point. That point, near the North Star, marks the axis of Earth's rotation. The whole sky turns in a perfect rhythm, and we, standing on a rotating sphere, are part of that dance. Even the path of the sun through the year follows a circle, though not a simple one. As Earth orbits the sun, the tilt of its axis causes the sun's position in the sky to rise and fall with the seasons. It climbs higher in summer, lower in winter, tracing an ever-changing arc. But if you could watch from above the solar system, you'd see the Earth following a nearly circular orbit, moving at nearly constant speed, returning to its starting point every 365 days. The year is a circle of time carved into space. The roundness of these motions isn't arbitrary, it's dictated by gravity and momentum. When an object moves under the influence of gravity, the most stable path it can take is an ellipse, a stretched circle. Planets, moons, and satellites all follow such paths, their motion balanced between falling inward and moving forward. The result is perpetual orbit. Motion that never ends, always curving, never colliding. From our vantage point, those orbits translate into cycles, days, months, years. Each rotation and revolution creates the rhythm by which we measure existence. The sky, through its circles, gives us time. Without those repeating motions, there would be no sunrise to mark morning, no seasons to guide growth, no celestial rhythm to structure our lives. Even the stars themselves participate in these circles. The Milky Way galaxy, with its hundreds of billions of stars, spins slowly around a central mass. Our Sun, along with all its planets, orbits that galactic centre once every 230 million years. The stars we see tonight are all moving in vast loops, so large and slow that they seem still to us. Yet over cosmic time, everything above us is turning, curving, circling, and within those circles lie countless smaller ones. The planets have moons, the moons sometimes have rings, the rings are made of particles that orbit individually, each following its own curved path. The sky isn't a collection of static points, it's a layered system of circles within circles, a hierarchy of motion built from balance. When we look up, what we're really seeing is a projection of those motions on the dome of the sky. The dome itself is an illusion, a flattened version of a three-dimensional dance. But the illusion is faithful to the geometry behind it. Every arc, every curve we see traces the same rule. Everything that moves in the heavens moves by turning. Even light, travelling from distant stars, bends into circular paths under gravity's influence. Around massive objects like black holes, space-time itself curves so strongly that light can orbit completely, trapped in endless rotation. These photon orbits are extreme examples of the same pattern. Energy following the geometry of the circle, because that's where the forces balance. We can see echoes of that circular behaviour in our atmosphere as well. The wind moves in spirals driven by differences in pressure and the rotation of the planet. Storms form when air begins to turn, gentle at first, then stronger, spiraling inward as energy concentrates. From above, a hurricane looks like a perfect circle, a colossal atmospheric wheel turning around an eye of calm. It's the same physics again: rotation, pressure, and equilibrium shaping motion into roundness. Even rainbows, one of the most familiar and beautiful phenomena in the sky, owe their form to circles. When sunlight passes through raindrops, it refracts, reflects, and bends. Each drop acts like a tiny prism, sending light back at a specific angle. Because that angle is constant, about 42 degrees, the light that reaches your eye from all the droplets forms a circular band. From the ground, you usually see only an arc, but from the air or from a mountain, you can sometimes see the full circle. The rainbow, like everything else in the sky, is round by the geometry of light itself. Auroras too form circular patterns, though on a larger scale. Charged particles from the sun spiral along Earth's magnetic field lines, colliding with atoms in the upper atmosphere. Those collisions release light, creating glowing rings around the magnetic poles. The colours and shapes shift, but the geometry remains. Curves of energy tracing invisible circles of magnetism. Even the dancing light of the aurora follows the universe's favourite pattern, and beyond the visible sky, the same principle continues. The radio signals from pulsars, rapidly rotating neutron stars, sweep across space in beams that turn like lighthouses, tracing circles as they rotate. The radiation belts around planets, the magnetic loops on the sun's surface, the vortices in Jupiter's atmosphere, all are circular structures of motion and energy. The sky is full of spinning, orbiting, cycling patterns, each one another layer of the same geometry. For most of history, humanity looked at these circles and saw perfection. The heavens seemed ordered, flawless, divine. It took centuries of observation to realize that even these circles are slightly off, orbits elliptical, rotations uneven, paths perturbed by invisible forces. But rather than diminishing the beauty, that imperfection made it deeper. The sky's circles are not static symbols of perfection. They are living processes, always adjusting, always responding to the pull of other bodies. Their roundness isn't absolute, it's dynamic, constantly maintained through motion. If you could stop time and see the solar system from above, you'd find a scene more complex and beautiful than any drawing. Each planet following a curved path around the sun, each moon tracing smaller curves around its planet, all of them moving together in one vast, graceful pattern. The entire system looks like a cosmic clock, gears within gears, but unlike a clock there's no start or stop. The motion continues without direction, balanced forever between gravity and inertia. And what's true for planets is true for us. The Earth's rotation creates day and night. Its orbit creates the year. The Moon's orbit gives us months, tides, and rhythms of growth. The same circles that structure the heavens also structure our lives. The light that warms you at noon has travelled across 93 million miles of curved space to reach you. The moon that moves the oceans also moves the rhythm of your body, its gravitational pull measurable in the smallest details of the natural world. You are living inside these circles, not beneath them. Every breath you take is part of Earth's rotation. Every shadow that shifts is part of its orbit. The sky isn't a stage where circles happen. It's the system that holds us all in motion. If you stay still and watch long enough, you can almost feel it. The stars move so slowly that your eyes can't see it directly, but your mind can imagine it. The whole dome of the night sky spinning gently around a distant axis, never stopping, never hurrying. The constellations are ancient, but their positions change over centuries, tracing even slower circles we call precession. The wobble of Earth's axis, completing one full turn every 26,000 years. The sky, even at its most still, is always turning. This circularity extends beyond motion into the cycles of the light itself. Every sunrise brings energy from the sun that plants absorb, turning it into life. That energy moves through food, through bodies, through ecosystems, and eventually radiates back into space as heat. The flow is circular, energy moving from the sky to earth and back again in endless exchange. Even the life in your own body comes from the atoms forged in ancient stars, now returned to the cosmos in every breath you exhale. You're part of the same circle of energy that began in the sky billions of years ago. In a way, the circle in the sky is both literal and symbolic. It's not just a shape, it's a pattern of continuity. Every orbit, every cycle, every rotation is a reminder that nothing in nature moves in straight lines for long. Everything turns, returns, renews, and yet within that constancy there's endless variation. No two sunsets are identical, no two moons quite the same colour or brightness. The circles of the sky repeat, but never exactly. The perfection lies not in uniformity, but in persistence. The sky keeps drawing the same shapes again and again, each time a little different, each time reminding us of the balance that makes existence possible. If you think about it long enough, the sky's circles begin to feel familiar in a personal way. The rising and setting of the sun mirrors the rhythm of waking and sleep. The waxing and waning of the moon mirrors growth and rest, energy and reflection. The slow arc of the stars mirrors our own cycles of effort and renewal. We measure our lives by these patterns, often without realizing it. Our internal clocks evolved under the sky's turning. Its circles are imprinted on our biology as much as on our calendars. And when we watch the sky, really watch it, what we're seeing is ourselves reflected on a vast scale. The same geometry that keeps our hearts beating keeps the planets in orbit. The same rhythm that guides our breath guides the tides. The sky's circles are not separate from us. They are the larger version of the cycles we live by. Somewhere beyond the visible edge of night, the Earth continues to turn, the moon continues to orbit, the sun continues to spin, the galaxy continues to rotate. The circle in the sky never ends. It only changes form as you follow it further outward. And as it does, it carries you with it, not as an observer, but as part of the same quiet, endless motion. If you think about it carefully, time has a shape. We don't usually imagine it that way. We treat it like a line, something that moves forward from past to future. But when you look at the world, the line never quite fits. The sky turns, the planets revolve, the seasons return, the body breathes and rests in rhythm. The same events, the same cycles repeat with small variations. Everything about existence points not to a line, but to a loop. The circle is the truer shape of time. We measure time using round things, the face of a clock, the orbit of a planet, the rotation of the Earth. Each second, minute, and hour is a division of a circle. The hands move endlessly around the dial, returning to where they began. Even when the numbers increase, the motion repeats. The ticking clock, the turning world, the circling moon, they're all parts of the same design, time expressed through rotation. When humans first tried to understand time, they didn't think of it as a straight path. They noticed its cycles, the repetition of day and night, of the lunar phases, of the seasons, all circular patterns. The earliest calendars were not rows of dates, but wheels divided into segments, tracking the turning of celestial bodies. Each year began not at an arbitrary point, but at the return of light after the longest night, or the first full moon after a harvest. Life depended on remembering when the circle would close again. The idea of linear time, the sense of past pushing into future, came much later. For most of history, people lived in cycles of growth, decay, and renewal. Farmers knew that the soil would rest and bloom again. Fishermen trusted the tides. Nomads followed the migration of herds. Their experience of time was circular because their survival depended on patterns that repeated. Even today, when we pretend to live by straight lines and progress, our bodies and minds still move by cycles. Your heartbeat is a pulse of repetition, contraction, and release. Your breath is a continuous loop of intake and exhale. Your sleep follows a circadian rhythm tuned to the turning of the planet. Every biological process, from cell division to hormone release, runs on cycles. Even your thoughts and moods shift rhythmically through the day. The arrow of time moves forward, but your experience of it is circular, shaped by the repetition of the body's rhythms. Science tells the same story in different terms. The Earth spins once every 24 hours, creating the day. It orbits the Sun once every year, creating the seasons. The Moon's orbit around Earth sets the rhythm of tides. Even on the larger scale, galaxies rotate. The universe expands in waves, and energy oscillates in cycles. Time is built from motion, and motion everywhere is curved. Einstein showed that time and space are not separate but connected, parts of a single fabric called space-time. When mass bends space, it bends time as well. That means time doesn't flow the same way everywhere. Near a massive object, gravity slows it down. Far from mass, it speeds up. The straight path of time becomes curved, warped by the presence of matter. In a literal sense, gravity makes time round. That curvature of time is measurable. Astronauts orbiting Earth experience slightly less time than people on the surface. Their clocks run slower because their motion and position in the gravitational field curve space-time differently. The effect is small, but real. Every orbit is not just a journey through space. It's a small loop through time, a circle that warps the passage of seconds and minutes. Even light follows this rule. When it passes near a massive object like a star, the curvature of space-time bends its path, delaying its arrival slightly. To us, that delay appears as a gravitational lens, a warped image of something farther away. But the bending isn't only spatial, it's temporal. Light itself experiences a change in the flow of time as it circles a massive body. The roundness of the universe, it seems, extends into time as much as into space. You can see this relationship in the simplest mechanical clock. Inside, a pendulum swings or a balance wheel turns. Each oscillation, each back and forth, measures equal intervals of time. The precision of that measurement depends on the perfect repetition of motion that traces a curve, not a line. Timekeeping itself is built on circular motion. The gears of a watch turn in constant rotation, each tooth pushing the next. Every second you count is a product of circular energy. In a deeper sense, the structure of matter and energy defines time's rhythm. Atomic clocks, the most accurate instruments humans have ever built, measure time by counting the vibrations of atoms. Those vibrations are oscillations, tiny circular motions of electrons within energy states. Billions of these cycles define a second. Time, at its most fundamental level, is the counting of repeated circles. This circular nature isn't just mechanical, it's also perceptual. Human memory doesn't record time as a linear list of events. It arranges experiences in loops of association. Certain smells, sounds, or places bring old moments back instantly. The past isn't lost. It circles back through emotion and recall. The mind bends time constantly, pulling memories forward, projecting the future backward, looping through experience rather than marching in sequence. You can feel this when you revisit a familiar place after many years. The light looks the same, the air carries the same scent. For a moment, time folds, and you exist in both moments at once, the present and the past touching at the edge of a circle. The straight line of years becomes irrelevant. What matters is recurrence, the loop of experience reconnecting with itself. In physics, recurrence is a real concept. Certain systems, given enough time, return to states very close to their original ones. This is called the Poincaré recurrence theorem. It suggests that even in a universe governed by change, repetition is inevitable. The molecules in a gas moving randomly will eventually come close to a previous arrangement. The same applies on larger scales. Given infinite time, every configuration repeats. The arrow of time bends back on itself. Our intuition of time as a circle may come from living in a universe where cycles dominate. Even entropy, the tendency of systems toward disorder, doesn't eliminate repetition. It simply ensures that the cycles change shape. Stars are born, live, die, and return their material to space when new stars form. Matter turns into energy, energy back into matter. The elements of your body were once inside stars, and someday they'll return there again. The life of the cosmos is circular, not linear. Yet despite all this, we experience time as forward motion, a one-way flow. That perception comes from the arrow of entropy. Energy spreads, order decreases, heat dissipates. The cycle continues, but always with variation. No 2 days are identical. No orbit repeats exactly. The circle of time, though repeating, is never perfect. It's a spiral, turning endlessly, but moving outward through change. That spiral is visible everywhere once you start looking. The planets don't trace the same circle through space each year. The orbit shifts slightly due to gravitational interactions. The seasons repeat, but the climate evolves. Even personal habits follow spirals. Routines repeated with small differences each time. Time's true geometry is circular motion with deviation, returning but never identical. The spiral, then, might be a better image of time than the circle or line. It combines both, the repetition of cycles and the progression of change. Every rotation carries something forward. The universe doesn't simply loop, it renews itself through motion. The galaxies rotate as they drift apart, stars orbit as they age, atoms vibrate as they decay and reform. Each circle is part of a larger sequence of transformation. When you think about your own life, the same pattern holds. You wake and sleep, work and rest, grow and age, cycles within cycles. Yet none of them repeats exactly. The days return, but you change. The circle moves forward. The past never disappears. It becomes the foundation for the next rotation. Time carries you along like a current moving through spiraling eddies, each one a moment, each one connected to the last. This combination of repetition and change gives time its texture. Without cycles, existence would be a single line of events, unmeasured and featureless. Without progress, it would be a static loop, endlessly repeating without growth. Together they create the rhythm that defines reality, familiar but never still. Even the perception of aging follows this pattern. Every cell in your body is replaced over time, every atom recycled. You're physically different than you were years ago, yet you feel continuous. That sense of continuity is your personal version of the circle of time, a loop that holds change within it. Your consciousness doesn't move in a straight line. It moves in cycles of attention, reflection, and renewal. The structure of memory supports this. The brain's electrical activity consists of oscillations, waves of voltage repeating in cycles. These brain rhythms synchronize with external cycles such as light and dark, or sound and silence. The very process of awareness is circular, patterns of energy turning endlessly within neural circuits. To experience time is to experience those cycles in motion. If time feels faster or slower depending on mood, it's because your internal rhythms shift. In calm states, cycles slow down. You notice more detail in each moment. In stress, rhythms speed up, events blur. Your perception of time expands or contracts with the curvature of your own biology. The mind bends time just as gravity bends space. The sensation of hours stretching or collapsing is a reflection of circular processes changing speed. Physics, biology, and psychology all point toward the same realization. Time is not linear. It only looks that way from a limited view. From within, it's circular, composed of overlapping cycles, mechanical, biological, emotional, cosmic. Every moment is part of multiple loops unfolding at different scales. The earth turning, the heart beating, the mind remembering, the universe expanding. Even death and decay, which seem like ends, are continuations of the same geometry. When a living being dies, its material doesn't vanish. It re-enters the cycle of matter. The energy stored in chemical bonds returns to the environment, absorbed by other forms of life. The circle of time closes and begins again in new form. In that sense, immortality isn't linear persistence. It's participation in the ongoing cycle. Nothing escapes time, but nothing is truly lost to it either. Every atom, every photon, every trace of energy remains within the universe's rotation. The shape of time ensures conservation. It bends endings into beginnings. Even on the scale of the universe itself, scientists speculate about cycles. Some cosmological models propose that the Big Bang was not the first event, but one in a series of expansions and contractions, a cosmic heartbeat repeating through infinite ages. In that view, time itself may be circular, with each universe giving rise to the next in endless succession. The universe breathes, expands, pauses, and collapses only to begin again. Whether that's true or not, the pattern persists in everything we can measure. Matter moves in orbits, energy in waves, systems in oscillations. Time, in every case, is the measure of cycles completing themselves. Even the word period in science means both a length of time and a single rotation, a linguistic echo of their unity. The circle of time explains why repetition feels natural to us. We find comfort in recurring patterns, in rituals and seasons, in the steady turning of days. Our brains evolved in a world ruled by those cycles, and our psychology reflects it. We're attuned to return. The sunrise doesn't bore us even though it's the same every day. It reassures us. The repetition of time gives stability to experience. At the same time, the subtle differences between each return, the changing colour of dawn, the shifting angle of sunlight, the growth of a tree since the last season, remind us that cycles evolve. The circle of time is not a closed trap. It's an engine of renewal. Each completion carries new information forward. Perhaps that's why humans invented stories that mirror time's shape. Narratives rarely move in straight lines. They rise, fall, and return. The hero leaves home and eventually comes back changed. The story's end connects to its beginning, forming a loop of transformation. Art imitates the structure of existence itself, circular progress that grows with every turn. If you could see time the way physicists describe it, as part of a curved space-time manifold, you would find no straight lines, only geodesics bending through a four-dimensional continuum. Every object follows the path of least resistance, which is never perfectly straight because the universe is filled with mass and energy. The curvature of space-time ensures that all motion, even time's motion, is rounded. So when you look at a clock or watch the sky turning, you're seeing more than markers of time. You're seeing representations of the universe's shape. Each rotation of the clock's hands mirrors the rotation of planets and atoms alike. The circle isn't just a tool to measure time. It's the geometry time itself follows. The phrase, "time goes around," isn't poetic, it's accurate. Every oscillation, every orbit, every rotation is a loop in time. The seconds that pass as you breathe are tiny cycles of atoms vibrating, while the minutes are defined by the planet turning and the years by its orbit. Your existence is nested within circles of motion, from the smallest to the largest. And though we speak of time moving forward, it may be more truthful to say that we move with it, carried in its circular flow. The future is simply the part of the circle we haven't reached yet. The past is the part we've already crossed. The path is continuous, and the centre, the present, is always turning. If you step outside on a clear night and look up, you can see this motion written across the stars. The constellations rise and fall as the planet spins. The night itself moves like a great clock face. That movement isn't just space rotating, it's time unfolding in a visible arc. The same circles that shape the sky shape the minutes you live, and within those turning minutes you are part of the same continuity. Your thoughts, your breath, your heartbeat, your sleep, all synchronized with the circle of time that turns endlessly around you. You don't move through time, you revolve with it. The shape of time isn't ahead or behind you, it's all around, wrapping every moment in an invisible rotation that never truly begins or ends. When you look far enough into the universe, you start to wonder if everything that expands must also return. It's an old question, older than astronomy itself. Does the universe move toward an ending, or does it find its way back to where it began? The more we learn about space, the more that question seems to echo in a circle. The idea that the cosmos might loop back on itself isn't just philosophy anymore. It's something physics continues to suggest, quietly, in the background of its equations. If you think about the universe not as a place, but as a system of energy and motion, the possibility of a return makes sense. Everything that moves in nature eventually curves. Straight lines, if you follow them long enough through space, bend under the weight of gravity. Light arcs, planets orbit, galaxies spin. Space itself curves around mass, and time curves with it. There are no infinite straight paths in a universe like that. Only great arcs that eventually close. Einstein's theory of general relativity gave us the first scientific picture of this curvature. It described space and time as flexible, bending around matter and energy. The more massive something is, the more it distorts the space around it. If the universe contains enough mass overall, then even the vastness of space could curve back on itself, forming a closed geometry. Not infinite, but unbounded, like the surface of a sphere extended into higher dimensions. In such a universe, a beam of light travelling far enough in one direction would eventually return from the other side. The cosmos would be finite but without edges, looping endlessly. That idea is difficult to imagine because our senses evolved in a world of straight horizons and open distances. We're used to the concept of space having boundaries, of distance increasing without limit. But the mathematics of a closed universe doesn't need edges. You can picture it like this. On the surface of the Earth, you can walk forever without falling off. You just keep circling. The surface is finite but unbounded. If space itself were like that, then the universe would be self-contained, curved through a higher dimension we can't see, looping back on itself in silence. Some early cosmologists believed that was exactly the case. In the 1920s and 1930s, models of a closed universe were taken seriously. They suggested that the cosmos might not expand forever but eventually slow, stop, and reverse, collapsing back inward in what they called the Big Crunch. In that model, the story of the universe would form a perfect loop, expansion followed by contraction, ending where it began. The next Big Bang could emerge naturally from the collapse of the previous one, creating a cosmic cycle of death and rebirth. The universe, like everything else, would be round. For a time, that idea fell out of favour. Observations of distant galaxies showed that space was not only expanding but accelerating. That acceleration, attributed to something we now call dark energy, suggested that the universe would never collapse. Instead, it would stretch endlessly, growing colder and emptier as time went on. Galaxies would drift apart, stars would burn out, and matter itself might eventually dissolve into radiation. A linear ending, the opposite of a loop. But even that picture, when you look closely, contains hints of circularity. Energy can't be destroyed, it only changes form. As matter decays, the radiation it releases spreads outward, and that radiation continues to influence the structure of space. The process never stops. Even if the universe expands forever, it keeps evolving through cycles of transformation. Matter into energy, energy into motion, motion into new structure. The loop may be longer and subtler than we can imagine, but the pattern remains. Physicists have returned to the idea of a cyclic universe in new ways. Some models propose that our cosmos didn't begin from nothing but from the collapse of a previous one. In these bounce models, expansion eventually slows, reverses and contracts, compressing space until quantum forces push it outward again. Each cycle erases most traces of the last, but the overall process continues. There is no absolute beginning or end, only endless renewal. Other theories suggest loops in time rather than space. In quantum cosmology, the concept of time itself may break down at extreme densities, such as those at the Big Bang. What we perceive as the beginning might be just a boundary between two phases of the same continuum. Time moving forward on one side and backward on the other, each a mirror image of the other's unfolding. The universe could loop through itself not by returning physically, but by reversing temporally, forever oscillating between expansion and contraction across the mirror of time. Even the idea of multiple universes, why the multiverse, carries an echo of circularity. Each universe in that model could be born from the energy of another, the process repeating endlessly. Every birth is a continuation of another's death. The system as a whole has no origin, no conclusion, only perpetual creation. It's a kind of cosmic metabolism, a cycle of expansion, decay, and renewal on a scale beyond comprehension. This looping nature doesn't have to be grand or mystical. It's a reflection of a deeper pattern physics keeps uncovering: equilibrium through repetition. Systems that oscillate are stable. Systems that move in one direction without limit are not. The universe seems to prefer motion that sustains itself. Waves, rotations, orbits, feedback loops. The cosmic scale is no different. Even entropy, which seems to drive everything toward disorder, produces cycles of structure in the process. Stars form from collapsing clouds of gas, burn, explode, and seed new generations of stars. Each round of death creates the material for birth. When you look at the night sky, what you're seeing is that cycle in progress. The light from distant stars comes from nuclear fusion, atoms combining, releasing energy, radiating across space. That light eventually strikes matter, warms it, or feeds another process that continues the chain. Even after the stars die, their elements persist, shaping planets, organisms, and eventually the awareness capable of looking back at them. Every atom in your body has completed that journey at least once. You are, in a literal sense, recycled starlight. So when physicists talk about the universe looping back, they might mean more than geometry. The cycle exists in matter itself, the flow of energy from one form to another and back again. Nothing stays fixed. Everything participates in transformation. The laws that govern energy and motion ensure that whatever expands will one day change, redistribute, and begin anew. Even in an eternally expanding universe, there are local loops. Galaxies form and collide, creating waves of star birth and star death. Black holes spin and evaporate, returning energy to the vacuum. Particles appear and vanish in pairs, fluctuating in the quantum foam of empty space. Each of these events is a small cycle nested within the larger flow. The universe, taken as a whole, is an ocean of circular exchanges, immense, slow, and unbroken. You can think of it as a hierarchy of loops. At the smaller scale, particles vibrate in quantum fields, energy oscillating in and out of existence. At the middle scale, atoms bond, molecules form, stars ignite, galaxies rotate. At the larger scale, cosmic expansion curves space and time, shaping the fate of everything within. Every layer mirrors the same rhythm: outward, inward, repeat. Even human history fits into that pattern. Civilizations rise, flourish, decline, and give way to new ones. Knowledge is lost and rediscovered. The cycles of progress and regression reflect the same physics, energy and structure flowing between order and disorder. The universe that loops back doesn't just exist in the sky. It expresses itself in every pattern of renewal you can observe. The idea that time and space might be cyclic isn't merely a poetic notion. It's grounded in symmetry, one of the most fundamental principles in physics. Conservation laws of energy, momentum, charge all stem from symmetries in nature. If the laws of physics are the same everywhere and everywhen, then time must repeat its structure. Loops are not an anomaly. They are the most stable configuration for a universe governed by conservation. Some modern theories go even further. They describe the universe as a kind of self-similar pattern, fractal in nature. Structures repeat at different scales. Clusters of galaxies resembling the webs of neurons, orbital systems echoing atomic ones. If you could zoom out infinitely, you might see that the universe as a whole mirrors the same patterns found within it. In that sense, looping isn't just spatial or temporal, it's structural. The same arrangements recur at different magnitudes, creating a cosmic symmetry that never ends. That concept has parallels in thermodynamics as well. The energy that drives expansion, the dark energy that accelerates space, may not be constant forever. Some theories suggest it could fluctuate, growing weaker or reversing over unimaginable timescales. If that happens, the universe's expansion might slow and eventually contract, closing the loop. The stars, galaxies and clusters would drift back together, compressing into heat and light before collapsing into a singular point, the seed of a new universe. The loop would complete, only to begin again. This model, this cyclic or ekpyrotic universe, borrows from both physics and ancient philosophy. In it, time doesn't begin or end. The universe continually renews itself through collapse and expansion, a heartbeat of creation at scales we can't perceive. Each iteration changes slightly, shaped by quantum fluctuations, but the structure remains. It's a cosmic rhythm that spans eternity. Whether or not this version is true, the underlying logic is consistent with what we observe in every other system. Cycles are efficient. They distribute energy evenly. They allow stability within change. The universe, in all its apparent chaos, follows that rule with extraordinary precision. The expansion of space, the oscillation of particles, the return of energy to equilibrium, all are aspects of a single circular behavior repeated across scales. It's not unreasonable to imagine that if we could somehow step outside time and space and look at the whole thing from a higher perspective, we might see a vast continuous loop, not a static ring, but a living circuit of motion and renewal. The universe expanding from one side, collapsing from the other, energy flowing perpetually through transformation. It wouldn't have a beginning or end, only phases. The Big Bang would be one of countless pulses in an infinite sequence. Even if the universe doesn't physically loop, there's still another kind of return built into its nature, the recurrence of form. The same basic patterns of structure appear again and again. Spiral galaxies resemble hurricanes, which resemble water draining in a sink. The dynamics of turbulence in air mimic the movement of plasma in stars. Simple laws produce self-similar outcomes, repeating endlessly in new contexts. Each recurrence is a kind of echo, a reminder that the universe reuses its own designs. And if that's true, then the universe doesn't need to loop spatially or temporally to express circularity. It loops through pattern and proportion. Energy finds balance in familiar configurations. Matter organizes itself in familiar ways. The circle of form persists even when the contents change. You can see that in the structure of galaxies. Most of them are spiral, rotating disks with curved arms that trace logarithmic spirals, a shape also found in shells, storms, and DNA. The recurrence of that pattern across such different scales suggests that nature doesn't forget what works. It repeats efficient geometries because they conserve energy and distribute force evenly. The spiral is simply the circle stretched through time, motion made visible. That tendency toward repetition might even extend to consciousness itself. The human brain is an oscillating system. built from cycles of electrical activity. Our thoughts, dreams, and perceptions arise from rhythmic patterns repeating in endless variation. Consciousness could be seen as a kind of resonance, a feedback loop of information between the world and itself. If the universe loops through physical forms, perhaps awareness is one of its higher order loops, reflecting the cosmos back onto itself. When you consider that possibility, the phrase, "the universe that loops back," takes on a quiet double meaning. It's not only the cosmos returning to its beginning, but the cosmos returning to awareness of itself through beings capable of reflection. Every time you observe the stars, every time you ask how the universe works, it has, in a sense, looped back, from matter to consciousness and back to matter again. You are part of that return, one node in the endless cycle of observation and existence. The light reaching your eyes tonight might have travelled for billions of years from galaxies long vanished. When you see it, the journey ends, and in that moment, the circle closes. The energy emitted by distant stars becomes experience in your mind, completing a loop that began before Earth existed. Even the act of perception is circular. Emission, travel, absorption, awareness. The universe looking at itself through you. And as the light fades, it continues on, scattering, absorbed again, radiated again, never lost, only changing form. Each photon, each particle, each vibration participates in the same unbroken flow. The universe doesn't simply exist in cycles, it is a cycle. Every process, every movement, every thought contributes to the grand motion of return. You can think of it like breathing on a cosmic scale. Expansion is the inhale, energy spreading, stars forming, space stretching. Contraction, when and if it comes, would be the exhale. Matter returning, energy condensing, equilibrium restored. Between those two motions lies everything we know: galaxies, life, time, awareness. The rhythm continues, steady, indifferent, eternal. Even if it never fully closes, even if the universe expands forever, it still loops in principle. The equations that describe it are symmetric. They work equally well forward or backward in time. The patterns of motion, the oscillations of fields, the conservation of energy, all express balance. The universe might not physically return to its starting point, but its laws ensure that every motion echoes through the rest. The loop is conceptual, not spatial. And if the cosmos one day grows cold and dark, its particles drifting endlessly apart, that too is part of the cycle. Over incomprehensible stretches of time, those particles may meet again, coalescing under gravity, igniting new stars. The loop might take trillions of years, but it will still be a loop. Nothing escapes the pull of balance forever. So when we speak of the universe looping back, we're not only describing an astrophysical theory, we're describing the deeper structure of reality, a preference for return, a bias toward repetition, a tendency for motion to find its way home. Every orbit, every vibration, every recurrence you can observe is a fragment of that larger truth. The universe moves forward by turning back on itself, endlessly creating the conditions for its own continuation. And in that endless motion, everything we know, everything we are, is part of the same quiet curve. Atoms once scattered in ancient stars, now forming the thoughts that wonder about their origin. The circle closes not in space, but in understanding. The universe, in asking itself what it is, completes its most intricate loop yet. Awareness returning to the source of awareness endlessly. When you imagine a sphere, it's easy to picture perfection. Smooth, balanced, flawless. The mind fills in its surface without edges or breaks, an ideal so simple it seems inevitable. But the universe doesn't make perfect spheres, it only gets close. Everything that's round, from the smallest droplet to the largest star, carries irregularities, slight bulges, dents, distortions, traces of motion and memory. The world, it turns out, isn't made of perfection. It's made of near perfection, constantly negotiating with the forces that distort it. At first glance, you wouldn't know it. The planets look round. The moon hangs in the sky as a perfect disk. The sun glows like an even circle. But perfection fades as soon as you look closer. The Earth, for instance, is not a true sphere. It's an oblate spheroid, wider at the equator, flattened at the poles. The reason is simple: rotation. As the planet spins, centrifugal force pushes outward along the equator, opposing gravity's inward pull. The faster the rotation, the greater the bulge. The same is true for Jupiter and Saturn, whose rapid spins make their equatorial diameters tens of thousands of kilometers greater than their polar ones. Every rotating body in space tells the same story: a compromise between motion and balance. Gravity tries to pull everything inward evenly, but spin redistributes that pull. The result isn't a flaw, it's the geometry of movement. Rotation gives stability to the system, but it also distorts symmetry. That tension is built into the nature of matter itself. Nothing stands still long enough to become perfect. Even if a planet could stop spinning, it wouldn't stay perfectly round for long. The pull of neighbouring bodies would stretch it into slight ellipses. The Earth's oceans, for example, respond constantly to the gravitational tug of the moon and the sun. The result is tides, bulges of water that rise and fall as the planet turns. The solid body of the Earth moves too, just less dramatically. It flexes by centimetres each day under those same tidal forces. The roundness of our world is a constant oscillation, never frozen, always shifting with the interplay of forces beyond itself. Temperature also affects shape. When one side of a planet faces the sun, it heats and expands slightly, while the far side cools and contracts. The difference is tiny but measurable. Over millions of years, such variations can change the balance of mass, altering rotation, subtly changing form. Even something as solid as a planet breathes, expands and contracts, its shape responding to cycles of heat, gravity and motion. The moon, which seems so serene and perfect from Earth, is also imperfect in subtle ways. It's slightly egg-shaped, with its longer axis pointing toward us. That's a result of tidal locking, the same process that keeps one side of the moon always facing Earth. Over time, gravity stretched it until the pull between both bodies reached equilibrium. What looks like perfection from our perspective is actually a frozen distortion, balance between attraction and resistance. The sun, too, for all its uniform brightness, is not perfectly round. Its surface constantly shifts, rising and falling with convection currents thousands of kilometers deep. Magnetic fields twist and knot, creating sunspots, flares and loops of plasma that arc into space. These motions distort the star's outer layers, changing its shape by fractions of a percent. The sun wobbles slightly as planets tug on it. It breathes with the rhythm of its own magnetic cycles. The perfection of its circle is only an illusion of distance. Even the stars beyond our system show imperfection. Rapidly rotating stars bulge dramatically at the equator, sometimes forming disks of ejected gas. Others pulsate, expanding and contracting rhythmically, their brightness fluctuating as their shape changes. Some stars are distorted by their companions, pulled into teardrops by mutual gravity. Every roundness in space carries a record of forces acting upon it, of motion never fully at rest. When astronomers measure these deviations, they learn about what lies beneath. A planet's oblateness, for instance, reveals its internal structure. Jupiter's large bulge tells us that it's mostly fluid, with little solid resistance. Earth's smaller bulge shows the balance between its solid crust and flowing interior. By studying imperfection, we uncover what perfection hides, the dynamic complexity beneath the surface. Even the smallest bodies in the universe follow this rule. Tiny asteroids and moons, too small for gravity to smooth them, remain irregular, lumpy, scarred by impacts. Their imperfection is more visible because their gravity is weak. Only when an object becomes large enough, when its self-gravity exceeds the strength of its material, does it start to round itself out. That threshold is called hydrostatic equilibrium. Beyond it, matter behaves like a fluid under pressure, flowing toward balance. But even then, the rounding is only approximate. Impacts, rotation, and temperature differences continue to shape and reshape it. The term sphere in science often means close enough. Planets, stars, and droplets approach the shape of a sphere, but never achieve it completely. Perfection in the real universe is theoretical. The true beauty lies in the attempt, the constant motion toward balance, the never-ending smoothing of roughness. You can see that process in something as small as a raindrop. When it first forms, it begins nearly spherical, shaped by surface tension pulling inward equally. But as it falls through the air, resistance flattens its bottom and stretches its top, turning it into a shape closer to a hamburger bun than a perfect ball. Small droplets stay round because air pressure is gentle on them. Larger ones distort, oscillate, and eventually break apart. Even here, in the simplest of natural forms, roundness competes with motion. The same principle applies at every scale. A soap bubble, for instance, forms a near-perfect sphere because air pressure is equal inside and out. But the instant it touches a surface or another bubble, that symmetry breaks. The points of contact flatten, creating a pattern of curves that adjust to maintain equilibrium. No two bubbles are identical, yet each follows the same rule. Minimize energy, find balance, accept imperfection. It's worth noticing how often imperfection creates beauty. The most striking landscapes on Earth, mountains, valleys, craters, canyons, all come from deviations from roundness. If gravity had its way entirely, the planet would be smooth, featureless, and perhaps lifeless. The unevenness of the surface makes ecosystems possible. Mountains change wind patterns, rivers carve pathways, and valleys collect water. The world's variety, its ability to support life, depends on its failure to be perfectly round. The same can be said of the sun. Its magnetic distortions, though they seem chaotic, create the solar wind that protects our planet from cosmic radiation and drives auroras in the night sky. The imperfections in its surface activity sustain the conditions that make Earth habitable. Too smooth, too stable, and the system would lose its vitality. The universe seems to depend on deviation as much as on order. Even on the microscopic scale, imperfection is essential. The atoms that make up matter aren't perfectly round. Their electron clouds are shaped by probability, by the influences of neighbouring particles, by energy states that shift constantly. Molecules bend and twist into complex geometries that make chemistry possible. The asymmetry in those structures allows for reactivity and variation, the foundation of life itself. Perfect symmetry, if it existed, would mean stillness, no movement, no change. Imperfection gives the universe texture, possibility, and time. It's a quiet irony that our idea of perfection, smoothness, symmetry, balance, is not how nature creates stability. A perfectly round object, if it existed, would be fragile. Any force, however small, would distort it. Imperfection, by contrast, provides flexibility. A planet with mountains can absorb impacts better than a smooth one. A star with magnetic irregularities can release built-up energy gradually rather than catastrophically. The unevenness of nature is its resilience. In our own lives, we mirror this truth more closely than we realize. Human faces, for example, are never perfectly symmetrical, yet those small differences give them character and beauty. The same asymmetry that distinguishes one person from another also signals health and vitality. In art and design, small imperfections often make objects feel more real, more alive. Perfect uniformity feels sterile, unnatural. The mind, tuned to the natural world, trusts imperfection. In physics, this trust is mathematical. The most stable systems are those that can fluctuate, those that allow small oscillations around equilibrium. Engineers design structures with flexibility to withstand stress. Bridges expand and contract. Buildings sway slightly in the wind. Spacecraft adjust constantly to maintain orbit. Absolute rigidity would mean failure. In a sense, everything that survives does so by embracing a degree of imperfection. That same principle applies to celestial bodies. Planets adjust their shapes over time, redistributing mass to maintain balance. The crust of the Earth drifts on molten layers, relieving pressure that would otherwise build catastrophically. Even the orbit of the Moon shifts gradually, transferring energy between Earth and itself. The imperfections of these systems are not flaws, they're the mechanisms by which stability is maintained. Astronomers studying exoplanets have found worlds that push these rules to extremes. Some orbit so close to their stars that their day sides glow with heat, while their night sides freeze. The difference in temperature stretches them into ovals. Others are tidally distorted into teardrops, their shapes permanently warped by gravitational pull. Some spin so fast that they flatten like discs. Each one tells the same story. Roundness as an aspiration, never a fixed state. The more you look, the clearer it becomes that imperfection is universal. It's in the spin of galaxies. Their arms unevenly distributed, their stars scattered irregularly. It's in the faint ripples of the cosmic microwave background. Tiny fluctuations in density that seeded all later structure. Even the expansion of the universe itself isn't perfectly smooth. It varies slightly in different directions. Those imperfections, small as they are the reason galaxies exist at all. Without them, matter would have spread evenly, forming nothing. The universe needed irregularity to become visible, to become real. So when we imagine spheres, the planets, the stars, the atoms, we should see them not as symbols of flawless geometry, but as records of motion in progress. They are never finished. They are caught mid-balance, constantly adjusting, constantly moving toward but never reaching symmetry. Their imperfections are the fingerprints of time and force. If you could touch the surface of the Earth as if it were a model in your hands, you would feel its unevenness, the bulge at the equator, the flattening at the poles, the ridges of mountains and trenches of oceans. You would feel a shape made by rotation, gravity, temperature, and history all at once. That's what an imperfect sphere really is. Not a deviation from a rule, but the embodiment of every force that has ever acted on it. The same could be said for yourself. You're not symmetrical, not static, not perfect. You're shaped by motion, by the push and pull of your environment, by the passage of time, your own roundness, the curve of your eye, the arc of your breath, the rhythm of your heartbeat is imperfect, and that imperfection keeps you alive. The universe doesn't demand perfection. It only demands balance, and balance always allows a little movement, a little unevenness. The circle, the sphere, the curve, all of them exist not as ideals but as living processes, adjusting constantly to forces they can't ignore. And if you look up at the night sky with that in mind, you might notice how every glowing circle, every distant world, carries traces of this same compromise. They're not perfect, and they never were meant to be. The planets wobble, the stars pulse, the galaxies twist. The perfection we imagine from afar is just the appearance of countless imperfections blending into harmony. In that sense, imperfection isn't the opposite of roundness. It's part of it. It's the movement that keeps the curve alive. Every dent, every bulge, every deviation is a sign that the universe is still working, still balancing, still in motion. Perfection, if it ever appeared, would mean an end. Stillness, silence, a frozen geometry no longer touched by time. But the world we live in, and the sky we look up to, are not still. They are full of motion, full of difference, full of the quiet irregularities that make everything continue. And as those imperfect spheres turn through space, they remind us that roundness, like balance, is not a state to be achieved, but a condition to be maintained endlessly by the patient hands of gravity and time. There's a quiet moment that arrives when you've been thinking about the universe for too long. It's not exhaustion exactly, but a kind of stillness, the realization that everything you've tried to separate keeps curving back into itself. Matter, energy, motion, time, sound, life. Every path you follow ends where it began. The circle closes not as a conclusion, but as a reminder that nothing in existence ever truly leaves its origin. It only changes form, returns altered, continues. The more you look at the world, the more it feels like one continuous system of returns. The air you breathe was exhaled by trees and oceans, by countless living things long before you. The water in your glass may have been ice once, or vapor in a storm, or part of a river that ran millions of years ago. The atoms in your body, carbon, oxygen, iron, were forged inside stars that lived and died before Earth existed. Even the light that reaches your eyes has been scattered, absorbed, re-emitted, recycled by matter along its path. Everything you touch is on its way somewhere else, caught in the cycle of transformation that never stops. That continuity isn't just poetic, it's physical. Every atom follows the same rules of conservation. Matter and energy cannot be destroyed, they can only change forms. The circle closes because it must. When a star burns, it releases radiation that travels across space, warms other worlds, becomes the energy for life, and eventually returns to space as heat. When something dies, its energy disperses, its matter dissolves, and new structures form from it. The circle is not a metaphor for life, it is life. You can see this process in the most ordinary moments. A leaf falls, decays, and becomes part of the soil that feeds a new plant. A drop of water evaporates, rises, condenses, and falls again. The warmth of sunlight today will radiate into space tonight, but some of it will remain, stored in oceans and air, continuing the planet's cycles of wind and weather. Every motion, every transformation participates in a return. Even thoughts move this way. An idea forms, fades, and reappears later in another form. Memory loops through itself, blending past and present. You can feel this when you remember something unexpectedly. The sense that time didn't vanish, but simply folded. The circle of awareness closes quietly, like a wave returning to shore. In science, the circular nature of existence shows up everywhere. Atoms bond and break, molecules assemble and disassemble, ecosystems exchange energy through endless feedback. On the largest scale, stars form from gas clouds, burn their fuel, explode, and send their material back into space to form new stars. On the smallest scale, particles oscillate in quantum fields, constantly converting energy between potential and kinetic states. The structure of the universe, from the microscopic to the cosmic, is built on processes that loop rather than end. The laws of thermodynamics define how these loops work. Energy flows from concentrated forms to dispersed ones, but never disappears. The heat you feel when you touch something warm is energy moving toward equilibrium. Over time, that balance spreads across larger and larger systems, but even that motion isn't purely outward. It creates new gradients, differences that drive new cycles. The universe sustains itself through this dance of imbalance and return. Even decay is part of renewal. If you follow this idea far enough, you start to realize that circles don't only describe motion, they describe relationship. Everything is connected through feedback, through exchange. The breath you exhale becomes air another being inhales. The energy you use returns to the environment, influencing something else in turn. Existence is cooperative in a way that linear thinking misses. Nothing ends. It just moves through another phase of the loop. The Earth itself is a living demonstration of this. Its systems, geological, atmospheric, biological, all circulate matter and energy. Volcanoes release gases that form air and oceans. Plants take carbon dioxide from that air, turn it into food, and release oxygen. Animals consume that oxygen, return carbon, and complete the exchange. Rocks form, erode, and reform. Water cycles endlessly. Even the magnetic field of the planet arises from currents looping through molten iron deep inside. Every layer of Earth, from the core to the atmosphere, moves in circles. You're built from the same principle. Your blood circulates, your lungs cycle air, your cells recycle their own material. Inside you, molecules are constantly broken down and rebuilt. Even your DNA repairs and copies itself in circular processes. The body you think of as fixed is in fact an ongoing motion, an ecosystem of loops maintaining balance. When you zoom out, the same rule applies to societies. Economies function through cycles of production and consumption. Knowledge passes between generations, refined and reinterpreted. Cultures evolve, decline, and revive. Even the rise and fall of civilizations follow circular dynamics, driven by the flow of resources and energy. History doesn't repeat exactly, but it rhymes in cycles because human behavior, like all natural processes, moves in patterns of tension and release. In the night sky, the pattern continues. The planets orbit the sun, the moon orbits Earth, the galaxy rotates, and the universe itself expands through curved space-time. Every circle you see above mirrors the circles below. The systems are nested within each other, loops within loops, each influencing the next. The circle closes not because things stop, but because motion integrates. There's a kind of comfort in this realization. It means that loss isn't absolute. Every ending folds into a beginning. Energy disperses but reappears elsewhere. A star collapsing into a black hole may seem like disappearance, but the energy it radiates in the process becomes part of the surrounding cosmos. Even the gravitational waves it sends ripple outward forever, adding to the tapestry of motion that connects all things. At a smaller scale, the same is true of you. Every word you speak, every movement you make changes the world around you in measurable ways. The air vibrates, molecules move, energy transfers. Those small ripples continue indefinitely, absorbed and re-emitted by other systems. The act of existing means participating in an infinite network of returns. If you consider the timeline of the universe, roughly 14 billion years since the Big Bang, the loops of return begin to stand out. Hydrogen, the simplest element, formed first. It gathered into stars, fused into heavier elements and scattered through space. Those elements built planets, oceans and organisms. And those organisms eventually became capable of thought, looking back at the stars that created them. The circle closes in awareness. The universe reflects on itself through the consciousness it produced. That self-reflection is not an interruption of physics, it's a continuation of it. The brain that thinks, the voice that wonders, the mind that perceives, all are arrangements of matter shaped by the same laws as the galaxies. Thought is another cycle of energy, another way the universe loops inward. Each observation, each question is part of the cosmic return. When you notice something beautiful, like the glow of dawn or the pattern of leaves, you're participating in that return. You are matter observing matter, energy recognizing energy. The line between observer and observed dissolves. The circle closes because the act of looking connects both sides. Even in silence, this motion continues. The atoms in your body vibrate. The electrons shift in orbit. The molecules exchange energy with the air. There is no true stillness. Even rest is part of a rhythm. The pause between breaths, the quiet between heartbeats, the moment between thoughts. The circle of activity always includes rest as one of its phases. That alternation between motion and stillness defines the structure of existence. Stars flare and fade, seasons warm and cool, minds wake and sleep. The alternation isn't random, it's necessary. Without pause, systems burn out. Without movement, they stagnate. The circle sustains both by letting each follow the other naturally. It's easy to think of circles as symbols of completion, but in nature, they don't represent endings. They represent balance. When one process finishes, its energy is already becoming part of another. Completion isn't closure, it's transfer. The circle closes only to continue. In thermodynamics, this principle has a precise name: equilibrium through exchange. No system is isolated forever. Heat, motion, and energy flow between boundaries until stability emerges. But even equilibrium isn't absolute. It shifts with context, expanding into larger systems, smaller loops within loops. The circle never freezes. It breathes. The same happens in consciousness. Moments of clarity and confusion alternate. You learn, forget, remember. Thought follows its own cycles of focus and drift. Awareness expands and contracts like a tide, carrying attention outward and then bringing it home. Each wave completes a loop of perception and the rhythm continues. This endless recurrence might sound repetitive, but it's what allows variation to exist. Each loop carries traces of the one before it, but never replicates it exactly. The circle is not static, it evolves. It gathers complexity with every turn, layering new information, new structure. That's why galaxies spiral rather than rotate in perfect disks. The asymmetry keeps them alive. The same holds for everything else. The circle closes, but it never repeats perfectly. You can see this truth even in human creativity. Art, music, literature, all are built on repetition with change. Melodies return with variations, patterns recur with new color or rhythm. The repetition makes them familiar, the variation keeps them alive. The balance between the two is what gives them meaning. The circle of creativity closes only by opening again. If you follow this idea all the way to its limit, it suggests something profound about existence itself. The universe might not have a linear purpose, no destination or goal, but it has continuity. It persists through motion, through cycles of transformation. That persistence, that return is meaning enough. The circle closes because motion requires it to. There's a quiet humility in realizing that the same laws that shape stars and galaxies also shape you. Gravity, entropy, and time act on everything equally. Yet within those laws, infinite diversity emerges. Every object, every life, every moment is a local expression of the same underlying motion. The curve of your eye mirrors the curve of the planet, which mirrors the orbit of the moon, which mirrors the curvature of space-time itself. The repetition isn't coincidence, it's coherence. And when the circle closes, when energy completes its path, when light returns to darkness, when motion becomes rest, it doesn't signal an end. It's simply the point of transition, the breath between cycles. Afterward, the motion begins again, just as it always has. If you step outside at night and watch the sky, you can sense this in the slow turn of the stars. Their motion is steady, predictable, endless. The same constellations that ancient people watch still rise and set, tracing arcs that will continue long after you're gone. You're watching the universe remember its own rhythm. The same pattern of circles that has guided everything since time began continues silently above you. And if you stay long enough, you might notice something else. That your own heartbeat, slow and steady, begins to synchronize with the world's motion. The rhythm of breath, the pulse of blood, the distant rotation of the earth, all overlapping cycles within one continuous field. The circle doesn't just close around you, it moves through you. You are part of its turning. Every system in existence seems to obey this law. To remain alive, it must circulate. To persist, it must change and return. The planets orbit, the air moves, the oceans flow, the cells in your body renew themselves. The moment anything stops entirely, it ceases to exist as part of the cycle. Movement is not just life's expression, it's its condition. The circle closes only by continuing to turn, and somewhere beyond the reach of our measurements, beyond the edge of galaxies and the lifetime of stars, the universe itself continues that motion. Whether it expands forever or folds back into itself, whether time curves or straightens, the deeper truth remains: everything moves in relation to everything else, and every motion finds its balance in return. You are living inside that balance, not apart from it, not observing it from a distance, but made of it. The atoms that carry your thoughts were once parts of stars, now reassembled into consciousness that can reflect on its origin. That reflection, in itself, completes a loop. The universe wondering about itself through you is the circle closing in the most intricate way possible. And as you sit quietly, breathing, thinking, listening, you're continuing that motion. Energy flows through you, air moves in and out, electrical signals circle through the brain. Every second is another rotation in a chain that began billions of years ago and will continue long after. The circle never stops, it only changes scale, endlessly curving through matter, through energy, through awareness. Somewhere stars are still forming, somewhere else others are dying, somewhere light is leaving one world and arriving at another. Somewhere, atoms that once formed a planet are drifting in clouds that will one day become something else. Every one of those motions belongs to the same circle. It closes constantly, quietly, everywhere. And in that motion, there's no final boundary, no end of the story. Only the turning, the return, the balance. The circle closes not to stop but to remind the universe, and everything within it, that wholeness has always been here, written into the curve of every orbit, every sound, every heartbeat, every thought, waiting patiently to be noticed again.